welcome everybody to the very first Augures workshop, Anticipating Agricultural Climate Shocks, Leveraging Science to Increase Policy Ambition, Farmers' Resilience and Food Security in Southeastern Europe and the EU. My name is Gaia, and I'm a program associate at Climate Strategies, and you all have received lots of emails from me, so apologies for that, and it's very nice to see you in person and some of you online as well. Before we start with the agenda for today, I'd like to introduce Andrzej, who's the CEO of Climate Strategies, for a few welcoming words. Andrzej?
Thank you so much, Gaia. And so just for some of you who may know us, Climate Strategies is what we call a research broker. So we sit between research and policy making, and our mission is to solve the most important most challenging topics of our times. So obviously climate change and agriculture, impact on agriculture is one of them. So we are very pleased to be the convener of this project alongside extremely skillful partners. So one of them is the National Observatory of Athens, together with NECCA, which is a weather consulting. If you guys could just raise your hands, just so that people see. Yeah. And Georgios, thank you. And then the second partner is Columbia University, and more specifically AgMIP. I think many of you heard this acronym, but just to say this is Agricultural Model Intercomparison and Improvement Project. So if you guys could raise your hands. Yeah, we also have a couple of colleagues online. Well, one thing I forgot to also mention that obviously we have a full room here, but we also have a dozen of people online. So this is a hybrid workshop, which will impact it a little bit. That it means we have to be a bit more disciplined in terms of when we break, when we restart, and so on, while keeping the informal atmosphere. So one other thing I want to mention is obviously one word of gratitude is towards the European Climate Foundation, represented here by our two amazing colleagues. If you guys could raise your hands as well. And I wanted to just say big thank you for, yeah, Joseph, you're also part of that. Yeah, I want to thank ECF for being a true co-creator of that. So thank you very much for being on that journey with us this year and in the years to come. So Augures, you may wonder, some of you may have checked, we picked that word because basically in ancient Rome, augur was somebody who can foretell events. And I think we very much hope that this event is a core and foundational part of our Augures project. The guy will tell you more about this, but essentially we are trying to build a service that aims to equip all of you, decision makers, farming stakeholders, with knowledge, the knowledge that we think is needed to understand and react to the consequences of climate change in the agricultural sector. So you're participating, I think, in a very important meeting where we worked for a good few months and we want to test our assumptions as we continue building that service that hopefully will be super critical for many, many policymakers, decision makers, and other stakeholders, first in the European Union, but later on worldwide. Maybe a word about why we think our approach is truly innovative. It is because it is very, very, very interdisciplinary. So we bring together weather forecasting, crop modeling, socio-economic impact assessment, and a true, honest stakeholder engagement in order to create that holistic picture of climate impact on agriculture in Southeastern Europe. The reason why we picked Southeastern Europe is because 12% of the GDP of the region depends on agriculture. So this is really crucial, and I think we wanted to start here and then go to other jurisdictions. Yeah, and I think maybe the last thing to say is this event we want to hold in Chatham, under Chatham House rules, so please do not attribute what you hear in this meeting to concrete individuals. We want you to open up, we want you to challenge us as the organizers, but also challenge yourselves, and we will challenge ourselves as well, right? So go beyond the official party line. This is not a meeting of the EU or any other official forum. This is a meeting that is truly meant to, well, start something foundational, something incredibly innovative, we hope. But tell us if you disagree, tell us if you think we should go a different direction, hopefully not, but any honest feedback, that's what this event is about. So I think with that, I can pass to Gaia so that she can introduce you to the project and to the purpose of this meeting in more detail. Thank you so much. And thank you again for being here. Yeah.
Thank you so much, Andrzej, for that great introduction. Yeah, so without further ado, I'll just delve into let me just do this for a second. See? The agenda for the day. So we're going to kick off with a overview, introduction from me, very brief, just to give you a bit of more context on the vision of the Augures project, the kind of research gap that we'd like to fill, and the multidisciplinary collaborations that this initiative is founded on. And then straight after that, we're going to go into our first panel discussion of the day, where we're going to invite some of the stakeholders that we have here today to reflect on these big questions of the most pressing priorities when it comes to address climate impacts within new agriculture, increase adaptive capacity for the consequences of climate change, and together work towards a more resilient food system. With the help of science. We're very interested in understanding how the provision of more information about climate risks can be helpful in for decision making. So we're going to hear from our participants in this reflection, where we're going to have the chance to really discuss these priorities from different perspectives in the ecosystem of different people that are joining us today. Then we're going to go into the technical part of the meeting, where our research scientists from the project are going to really show the methodology behind the Augures project, this kind of cascade, if you want, science effort, where the output of one modeling exercise becomes the input for the other one, and this is kind of where the real interdisciplinarity really shows. And we're going to have time for extensive Q&As, and after this, we're going to break for lunch. And we also invite our online participants to take a break, of course, but very much encourage them, if you can, to come back for the afternoon sessions. In the afternoon, we're really going to have the chance to delve into the kind of prompts and discussion points that we touched on in the morning in a more informal setting, where we're going to have two different interactive sessions on in person, which we will choose from, and one online as well. After the activities of the interactive session, we're going to have a much needed coffee break. And then we're going to come back to the plenary for a discussion where we're going to see what the outcomes of the discussion of the interactive sessions are, and really try to bridge the gaps and these priority areas that we want to highlight together. And finally, we're going to finish with a afternoon panel where we're going to delve into the different examples of multi-stakeholder collaborations that are needed in order to enhance resilient agriculture and food security in Southeastern Europe, the EU, and also beyond globally. And now I think it's a very good time to introduce our graphic recorder. We've got Krista Petala here with us today. Chris is an exceptional note taker. I think that's a good way to put it. So throughout the whole event today, Krista will be taking notes of our conversation, really trying to focus on creating a visual map with illustrations that is gonna be useful, especially in the afternoon discussion, to visualize all the things that we discussed together and also facilitate a discussion and the kind of outcomes of today, really, like trying to understand how we can visually identify the steps that we need to take moving forward. Okay, so I think now I will just quickly go into the introduction of the project. And I will start from maybe trying to give you a little bit of a glimpse of the problem that we started from, which, like any climate-related problem, is of course very complex and it's got many different dimensions to it. So if you think about the way in which the agricultural sector impacts climate and which climate impacts the agricultural sector, there is of course like a mutual kind of relationship. We see that agriculture accounts for a very significant amount of emissions. In the EU, is more than 10%. But at the same time, we know that climate impacts agriculture production and poses a risk to the production. But at the same time, context-specific information on the ways in which climate impacts agriculture is not always accessible, is not even always available, and needs to be improved for this reason. At the same time, it's very difficult sometimes to align research timelines and priorities to the timeline and priorities of decision makers and practitioners. And something that's been really relevant for the EU, especially in the past year, is really being aware of how when rural communities and farmers are not included in these conversations, then and in the knowledge creation process, also in the scientific conversation, that poses massive challenges when it comes to policy implementation, because it's not an inclusive conversation. It doesn't take into account the priorities of the people that are really much on the front line. So with this in mind, what kind of vision do we have for this project, and not only for the project, of course, but for the project as part of an ecosystem of holistic solutions that should kind of take us towards a more resilient agricultural sector? So we would like to envision more precise information on climate impacts to help to scale up adaptive capacity, but also to serve as a motivation for more ambitious climate action. We want to improve multidisciplinary collaborations to improve the quality of predictions and climate impacts in agriculture. And we want to facilitate regular engagements with decision makers and practitioners to really ensure that research is tailored to policy. And last but not least, we want to foster a diverse community of practice where people from different groups can come together to discuss opportunities for inclusive transitions for resilient agriculture. And so this is how Augures came along in terms of idea. And in the past few months, we've been working to make that idea a bit more concrete with the help of our partners. So this is what we've been focusing on for 2024. You're going to hear more from the technical side from our scientists, as I said. But we're really looking at crop modeling for the whole of Southeastern Europe, and then additional economic analysis with a focus on Greece. We are focusing on corn and wheat as our crops of choice for this year. And as we mentioned many times, we have these coordinated efforts, which includes climate, crop, and economic modeling, as well as strong stakeholder engagement component. And this is only the first of what we hope is a long series of engagements with people that are interested and collaborate with us in the project. The outcomes are things that I just mentioned, I think, really trying to work together towards resilient farming, food security, secure agriculture in the EU, and also really working towards spreading awareness about climate impacts by making science accessible, but keeping it reliable and evidence-based, essentially. I think Andrzej already mentioned the partners that compose this multidisciplinary team. I'll also add facets as the partners who provide strategic and scientific advice to the project. And this is really a great team that's come together from different parts of the world and work together in the past few months to achieve the first results. So really very quickly, I'm just going to reiterate the objective of this workshop today. And you may notice how we would like to really keep it a quite informal setting where you feel free to share your ideas. Because from our side, what we'd like to demonstrate is, first of all, the potential of integrated modeling as a decision support tool within the Augures framework. So not only what we have started to do, but I guess what we can do and what is the most relevant thing that we can do. Then gather your feedback to shape our future research outputs based on key priorities for different groups. And also, as I said before, started to build an international community of practice. So we really hope to stay in touch after this workshop as well, so that you can follow the way in which we listen to this kind of feedback and implement it in the next iterations of the project. And some ideas, I'm just going to conclude with some ideas that we are actively exploring right now in terms of where the project could go in the future. So we'd like to see whether this methodology can be scaled up and applied to more extended geographical areas, to different timelines, because so far we've been working with seasonal forecasts. So we'd like to also explore longer timelines and different crops, of course. For example, olives are very relevant for the Mediterranean countries. So I'm going to stop here We're just going to go straight into our first panel, but after that, there's going to be time for questions. So if you have questions about this presentation, you can do that then. Okay, perfect. So thank you, Andrzej, for your contribution. I'm going to call to the stage now our partner, Madajewicz, who's going to moderate the first panel of the day. Climate impacts in EU agriculture and food system, understanding the context to unlock the solutions. I'm gonna start here to monitor the slides, but the floor is yours. Okay.
Thank you very much, Gaia. Good morning, everyone. Really happy to have the opportunity to meet you all. And Malgosia Madajewicz, I'm at the Center for Climate Systems Research at Columbia University, where AgMIP is based. I'm an economist by training, work on adaptation to climate change in both agricultural and urban settings. Very briefly then, to introduce the session, as Gaia already introduced, the objective of this project is to develop climate information that can support, help design and implement policies, interventions, and help make decisions that can make the agricultural sector more resilient. And when I say climate information, I mean broadly. So not only information about current climate and climate forecasts, but also information about impacts, whether on crop systems or on economic systems. In order to achieve this objective of producing information that is going to be useful, it would be helpful for us throughout the workshop today to keep in mind examples of policies, programs, and decisions which are already being designed or implemented to improve resilience in agriculture, and also policy gaps, policies that maybe are not yet being implemented but are needed, as well as the extent to which the existing policies and decisions are already being supported by climate information, and the extent to which there is new information that is needed to support existing efforts, and to perhaps it's one of the obstacles to developing policies that do not yet exist but are needed. So this first panel will provide some examples of policies, interventions, and decisions that we can think about throughout the day today as you hear about the information, the climate information that the project is developing. So I'm just going to introduce the panelists one at a time, who will provide us with these examples to seed the discussion for the day. Our first panelist is, and forgive my pronunciation, I didn't have a chance to check it. Nicola Di Virgilio is online, is that right? Is Policy Officer in Unit B2 Environmental Sustainability at the Directorate General Agriculture and Rural Development in the EU Commission. Nicola graduated in agricultural science at University of Bologna with a PhD on sustainable use of land, has a background on research and innovation on climate change and agriculture. And the main policy topics in the Commission that he focuses on are sustainable carbon cycles, climate mitigation, and adaptation in the Common Agricultural Policy. Just before Nicola starts speaking, the one thing that I omitted to say is we will have 4 presenters, each will present for 10 minutes, and then we'll have a half an hour for questions and discussion with the presenters. So if you could just write down your questions and hold them for that last half hour. Nicola, please, thank you for being here.
Good morning, everyone. I hope you can hear me. Can you please?
Yes.
Okay, super. Thank you very much. And I'm very sorry I cannot be there today with you, and it's a difficult moment for us to travel. But I'm very happy to listen. I mean, a lot of things that you already mentioned in these few minutes are actually perfectly in line what we think at the Commission in terms of adaptation and resilience of the agricultural sectors, and also in terms of need, what is missing. My intention here is to today, of course, not to repeat all the impacts of climate change on agriculture, but just to give you maybe as a starting point an overview, an umbrella overview on the policy initiatives in EU when looking at adaptations and resilience of the agriculture for the agricultural sectors, which is very important. And I like to remember this not only for ensuring food security, which has been mentioned today already, but also all the other function of the agricultural sector, which is also provide, for example, biomass for the development of the bioeconomy, but also, for example, the provision of ecosystem services like carbon removals, water filtrations, biodiversity, and so on. So resilience is ensuring resilience is important not only for food production, but also for all these other functions of agriculture, which are actually all interrelated. I have to say that the adaptation and resilience gained more importance with the Green Deal, also in the agricultural sectors. And of course, in EU, there is an adaptation strategy to climate change, which underlines, particularly in its review in 2021, that we need to act faster, smarter, and more systemic. These are the key words that are there. And then be not isolated in taking decisions, but really brings a multi-stakeholders approach there. And if we look at the climate law, which basically set the objective of the climate neutrality by 2050, we have a more reinforced provision on adaptation, where it's asked to ensure continuous progress in enhancing adaptive capacity, strengthening resilience, and also reduce vulnerability to climate change. So even when we talk about mitigation, so emission reduction, adaptation is always there. And very recent, in March this year, the Commission published the first European climate risk assessment report with the help of the European Environmental Agency, basically bringing together a lot of informations and knowledge from scientific literature, together with the report produced by the Intergovernmental Panel on Climate Change, and the help of the Directorate General of the Joint Research Center of the Commission. And for the first time, we have an European-wide assessment of the risk related to climate change. The idea was to identify the main risk, the priority area where to act, and the report identified 36 key risks for Europe, many of which have already reached critical levels and could become catastrophic without urgent and decisive actions. And the report identified, for example, that the food value chain and the ecosystems, they are priority sectors where climate risk is significant and where action are necessary. So and identify indeed also that the highest intensity of those risks are anyway for southern European areas. So that's basically, it gives the idea that how important is to work on this sector, and of course identify several specific risks for the agricultural production, which I'm not repeating here because you might know them very well. And following to this assessment of the climate risk, the Commission produced a communication again in March this year on managing climate risk. So there you have basically the proposal of the Commission in terms of actions to respond to this assessment of risk, and with, of course, a focus also on the food sector, because it has been identified as a critical sector in this context. So basically, we propose three main overarching horizontal actions. One on governance, where we need greater clarity about the responsibility and the owners of the risk, in order to create links among the different level of governance in EU. Because this is important when we talk about resilience. It's not only one single stakeholder that is owning the risk, but it's really the problem can only be solved if the decisions are coordinated at different level: local, farm level, local, regional, national, at European level. That we also important to finance resilience and transition. And then there will be new tools that we will be discussing in the Commission on how to facilitate that, the whole farm transition to more resilience system. But particularly it emphasized the need for improving tools, decision supporting tools, to improve access to data, to model scenarios, future scenarios, really for having a more informed decision making. So it's perfectly in line with the scope of your project. And it's really identified also by the communication that this is still missing, and then a project like yours can really help on that. What else? I think that it's important to mention also the common agriculture policy. Since the new common agriculture policy, adaptation gained special importance, because in one of the different specific objectives, adaptation is clearly mentioned as together with mitigation, bioeconomy, and so on. So this means that the member states, they had to identify their need in terms of adaptation. And if we look at what member states did in the preparation of their strategic plans of the common agriculture policy, all of them identified that there are needs in terms of adaptations. Of course, those needs are different depending on the member states, and even within the same member states, but more member states recognize that, and they activated several typology of supports, voluntary supports, or conditional supports to receive support of the CAP, conditional requirements, sorry, to receive support from the CAP, to face those needs identified by member states. We published in 2023 a summary of the Common Agriculture Strategic Plan, programmed by member states, and we can see there that more than 25% of the European utilized agricultural area will be supported, is planned to be supported with commitments to improve climate adaptation. There are several examples here that if you are interested, we can talk about, but it goes into investment for better water management, but also for pushing the changing of crops with more resilient crop, less water demanding crops, and a lot of landscape features to be included. All those practices that increase the resilience at farm level, including the increase of soil organic carbon, which is very important for the retention of water and drought. And on here, I would like also to mention the fact that the Commission is already, there is a framework regulation on the certification of carbon removals in the land sector as well. And that will give the possibility for farmers to be rewarded for the efforts of sequestering carbon in soil and biomass, and even from the development of voluntary market. So that's we are in the progress of producing the specific methodology for the certification of different removals. And when we talk about removals in the land sector, so increase of soil organic carbon, increase of biomass, increasing of carbon in biomass, so protection against strong winds as well with landscape features and increased biodiversity. These are all in the same direction of increasing, trying to increase the resilience at farm level. we have a problem on how to measure climate adaptation, how to measure the effectiveness of those measures in terms of increasing the resilience. We try to, we will publish very soon an index, an impact indicator as part of the Common Agriculture Policy, which is called Agricultural Sector Resilience Progress Indicator, developed together with the GRC. But there you see, for us, how it has been challenging to produce something like that, where we are trying to combine the different components that makes a farm resilience, from the economic angle, from the biophysical angle, from the social and policy support, political context angle, and we put all these components together, and we try to identify an index. We can share more details if it's this is on your interest, but we see that it's not really a quantification. It's like, okay, you can see a trend in all of those components, and then try to summarize those components. For example, one is the water exploitation index, the other one is organic carbon, another one is a comparison of the variability, stability in production to a reference year. But it's really challenging also to communicate the result, this index, because you may have a value for it, but you really have to go to the component that makes this value in a way or another to explain why in a certain situation you have a trend of increasing or decreasing resilience. So this is really something that is needed from project like you. And maybe Gaia, if you can go to the second slides, please. Here I tried to summarize a little bit what we can maybe have in terms of need that still needs to be addressed, and then maybe project like yours can help on that, and it can also be somehow some input for the following discussion. We need information, indeed, as you said, which are useful. And in the work we have done also in the preparation of this document that I mentioned already, it was very challenging for us to find information on the impact on climate change on sub-sectorial agricultural sector. For example, okay, most of projects are focusing on maize, on wheat, because they are main commodities, but we also need, for example, what is the impact on livestock production, for example. What is the impact on biomass production for the bioeconomy? This is also very important, because for policy design, to design specific measures which are in the agricultural sector, they really needs to be adapted to the types of agriculture, to the types of production. And also for us, it's important for this exercise to identify hotspot area where there are more vulnerabilities, and where we can maybe focus for some specific policy interventions. Those models also needs to help policy coherence, because there are several interconnections between the different sectorial policies, and the sectors and the societies asking from agriculture a lot of different things, not only food, as I was mentioning. So those models really needs to be holistic, in the sense of not only looking at agriculture itself, but also at the interaction of agriculture with other sectors. And the provision of agriculture of all those ecosystem services and all those materials that are there. Which kind of solution? Do we focus more on natural-based solution? Do we focus more on infrastructure? Do we want short-term action or more system transformation and land planning? I think models should also help to reply to those questions, and also to identify actions which brings maladaptation, for example. You see, you know better than me that climate change creates cascading effect on water and food and energy. They are all connected, and also even on human health. So those elements are also important to be represented in models. And what we need, unfortunately, is high resolution decision supporting tool. because unfortunately in agriculture, all the different site-specific conditions requires really to have high resolutions in terms of spatial resolution, but also in terms of time, maybe seasonal forecast or a little bit beyond seasonal forecast. It's important because we always say to the farming sector, okay, we need to have a transition to a more resilient system, but then to which system? What is going to be the situation in 20 years, which is probably the time needed for a region to switch to a different system, this system of productions with the whole supply chain that is created. Where are we going to go? What can we suggest now to farmers in terms of new crops if we don't know exactly more or less what is going to happen in 20 years in terms of weather condition and climate condition? And as you mentioned, these models are also very important for capacity buildings to push innovations. In the CAP, we have tools which are called, for example, the operational groups, where we support projects where farmers are together with the researchers to implement actions and solutions. And we have several examples on climate adaptation. Again, it would be good to show the impact of those, or to create good examples and that can be communicated and replicated. Yes, I mean, the last 2 points I kind of already touched the necessity to represent the diversity in the farming sector, and please, the lack of pragmatism is also sometimes what is hampering the implementation of strategies. There is a lot of complexity here. And I think the challenge is really to find where is the compromise for an effective communication and start with actions which are not regrettable and it can bring to a more resilient farming sectors. I hope I gave a little bit on overview what is happening in the EU. Of course, there are much details behind there, and happy to stay for questions and in the case are necessary, or provide materials later on, even in the written. Thank you very much.
Yes, thank you very much. That was very comprehensive and super interesting. So I'll just introduce the next speaker, Antigoni Voudouri. Again, I hope I'm not terribly mispronouncing your name. She holds, and thank you for being in person with us. Antigoni holds a bachelor in physics, MSc and PhD in environmental physics and meteorology from the University of Athens. She has worked as a meteorologist, forecaster at Hellenic National Meteorological Service, as a researcher on climate change issues at the National Center for Environment and Sustainable Development, on atmospheric modeling and air pollution modeling at the Laboratory of Environmental Physics of the University of Athens, and at the Institute for Environmental Research and Sustainable Development of the National Observatory of Athens. She has participated in national, European, and international research programs on numerical weather forecasting, early warning systems in Southeastern Europe, and climate change adaptation and resilience. She's published work in international scientific journals and conference presentations. She's currently the head of Sustainable Development and Climate Change Directorate at the Natural Environment and Climate Change Organization.
Thank you, Antigoni. Thank you, Antigoni.
Thank you for the introduction.
It's enough space.
Yes, yes. Good morning, everybody. We want to talk on the microphone. Okay.
The online.
Okay. So I will start with a small presentation of NECCA, as we call it shortly, the Natural Environment and Climate Change Agency, which is a quite new agency. It's actually the Environmental Protection Agency of Greece. It was established in 2020, and it is supervised by the Ministry of Energy and Environment. So the main goals of NECCA is implementing policies that are formulated by the ministry, but under the umbrella of NECCA, it is the management of all protected areas of Greece, and also the biodiversity conservation. And we also implement and design actions and policies that they are related to climate change, mitigation and adaptation. So coming now to our, let's say, close to your project, regarding climate change, as I already mentioned, NECCA implements the policies designed by the Ministry of Environment. So we have recently, 2022, in Greece, we have the new national climate law, which in a certain way arranges or gives an overview of the plans that Greece has in order to be resilient in climate change issues, but also adapt to climate change. So at this framework, agricultural sectors and farming sectors, especially large units of livestock, are obliged, according to Article 19 of the Climate Law, to reduce their emissions by 30% until 2030. And we, as an agency and as an organization, we are also developing and already we have already delivered a platform in which business enterprises and municipalities are obliged to deliver their report regarding their plans on minimizing their emissions on SO2. So this is one of the aspects that our agency is working on regarding mitigation, mainly mitigation of climate change. But we also, as an agency, we are partners in the largest project that is taking place in Greece, which is the Life IP project. It is a Life IP Adapting GI project. It's a European project. It has a duration of 8 years duration. This project has to do with the plans of Greece in order to adapt into climate change. And at the framework of this project, several sectors have to design and promote their plans in order to adapt into climate change. Agriculture is one of these sectors. So in order to help agricultural sector to adapt into climate change, at the framework of this project, 28 indices, and I heard from the previous speaker that there will be an overall index regarding agriculture. We have now sent, we have designed, not us, our partners, but we are responsible for gathering all this data from Ministry of Agriculture and from other organizations. And we have sent them a list of indices describing, for example, how their needs on water, their needs on their plans on introducing new varieties of plants that they are resilient into climate change. And so we are gathering all these indices in an attempt to see how we could agriculture. I'm focusing on agriculture as this is your main project. How they could monitor and assess their adaptation plans in order to have a more resilient agriculture. Of course, there are other sectors of the economy that they are also need to adapt, like livestock, tourism, economy, and so on. But I think that this sector, the agricultural sector, is very close to your project.
So, yeah, thank you very much. Very good overview. So our third speaker is Federica Matteoli. She has over 2 decades of dedicated experience establishing a distinguished career as a project manager specializing in climate change, political science, and participatory approaches. She has contributed significantly to international agencies such as the Food and Agriculture Organization and World Bank, as well as various government agencies. Holding a PhD in science and management of climate change, her academic background has been a cornerstone of her professional journey. Her expertise spans the coordination of global and developing country projects related to climate change, with a particular focus on managing and assisting local sites. Thank you very much, Federica, for joining us with these comments.
Thank you very much, especially for the organizers. I received this invitation from my director I think last week. So, and the organizer was very, very, very nice on organizing everything. Thank you very much. I'm glad to represent FAO today with you, and my speech I try to divide the speech in 4 parts. The first part will be on FAO strategy on climate change to address climate risk. The second part will be the collaboration between the FAO and the European Union. I think it's important to underline what FAO and EU are doing on climate risk. And the third part will be the role of science, policy for addressing climate risk, and the gaps that we need to address. And I will give you some examples of collaborations and tools or projects. So the FAO strategies on climate change focuses on several key policy areas to address climate risk for agriculture. The first one is, of course, climate change mitigation adaptation to involve programming practices to reduce the greenhouse gas emissions and to enhance the resilience of agricultural systems to climate impacts. And the other important topic is the protecting and sustainably managing biodiversity and natural resources, but more focusing on climate risks. I think it is important to underline the fact that the FAO strategy will try to ensure food security and building resilience, livelihoods, and supporting communities in adapting to climate change and mitigating its impact on food production. All of these is done enabling climate and water-informed decision-making through the co-production and the communication of climate services in agriculture. I will give you some examples during the presentation. And developing policies is another important element, because we need to take in consideration that without developing policies and investments that promote sustainable agri-food value chains, we cannot develop any tools, any important models. We need to have an approach, an holistic approach, taking consideration all the aspects and all the actors involved in these activities. Another important part is leveraging digital technologies and innovations to transform food systems and improve their sustainability and resilience. Another important aspect that FAO is doing is the climate risk management. We try to integrate climate change and disaster risk consideration in FAO's upgraded environmental and social safeguard system through the identification of climate risk and their integration and management across the FAO's project cycle. What does it mean, this long sentence? Is that we are trying to, we have a specific way to produce projects, and we decided to make climate risk as an important element in this process to produce projects in the project cycle. Collaboration between FAO and EU is on climate change through several strategic initiatives and projects. The first one is to develop strategic dialogues to review progress and set priorities. This is why, because without, as I told you, without debates, without dialogues between all the stakeholders, we cannot achieve the results. And of course, you provide substantial funding to FAO projects. In 2023, the EU contributed a lot, supporting 179 projects globally. Policy and knowledge sharing is developing guidelines, standards, and policies that promote sustainable agricultural practices. These include digital technologies and innovations to enhance the sustainability and resilience of food systems. And at the ground level, the initiative FAO and EU are developing are on recovering green recovering projects, climate change adaptation, and of course mitigation efforts and biodiversity protection. Some example at the global some example in the ground the larger grant funded project by the EU in Papua New Guinea in the Pacific on supporting rural entrepreneurship, investment, and trade. And with this project that started in 2020, 82,000 households have been achieved and receive the benefits from this project. At the global level and at the global advocacy and outreach, both organizations emphasize the importance of integrating food security and climate action to achieve sustainable development goals. What does it mean? This means that, for example, at the COP28, collaboration between FAO, EU, and other international organizations achieved an important goal, a declaration on sustainable agriculture, resilience, food system, and climate action. FAO and EU are both supporting this initiative. Maybe you can think that this is not this declaration doesn't have impact at the field level. This is not true because, as I told you, we need to work at the field level with farmers, with governments. But at the same time, if we don't have this kind of declaration that push governments to achieve goals and to achieve results, there is a gap in the process, and is more difficult for everybody to achieve these goals. In June 2024, FAO and EU became members of the steering committee of the UNFCCC Climate Resilience Food System Alliance, who is an alliance that addresses climate risk, climate resilience, and climate weather resilience. Let me give you an idea what FAO thinks of what is the strategy for science. For FAO, science is a crucial element in reinforcing efforts to address climate change in agriculture. There are many approaches, there are many activities. One for climate change is techniques such as the identification of practices and techniques such as reducing tillage, cover cropping, agroforestry are being promoted to increase soil organic carbon. This is another element that we need to take in consideration. It's important to have models to identify how much water is in the soil, how much water is at the ground level. It's important to have drones, satellite information, but at the same time, it's important to through this information, through this data, to identify practices at the field level to help farmers. And in this case, also FIU has been supporting the Global Soil Partnership that is hosted by FAO. As I mentioned, also advances in precision agriculture technologies, such as drone, sensor, satellite imager, and are helping farmers to optimize resource use and reduce environmental impact. One tool that FAO has, just as an example, is ASIS. This is the Agricultural Stress Index System tool that allows easy identification of areas of cropped land, especially the water stress. Water forecasting and climate modeling are providing farmers with better information to make informed decisions about the planting, irrigation, and harvesting. These can help on mitigating the risk associated with extreme weather events. An example is the collaboration between FAO and EU in the Horn of Africa initiative. The initiative integrates food system into an early warning system and on adaptation to climate risk. However, despite these advancements, there are still significant information gaps. First one, we need more research to understand the long-term impacts of various climate agricultural practices. More studies on how to scale these solutions in a better way. And important element is to understand the economic implication of adopting new technologies, especially for farmers, because farmers don't have financial support to use these tools, to use these technologies. So we need to work with governments, to work with other entities, banks, maybe investments, to support farmers in these, to be able to use the new technologies. More integrated research that combines various disciplines, such as agroeconomy, ecology, economics. And so only addressing these challenges we can do with a combination of policy support, financial assistance, education, and infrastructural development. And I think to receive today a good example by this project, Augures, by addressing these gaps. Science can strengthen efforts to create a sustainable, resilient agriculture system, especially for small-scale farmers. But we need an holistic approach to involve all the stakeholders, from the governments to the banks, to the investment banks, to the international organizations, farmers associations, and and also we need to take in consideration the context-specific element, because some practices are can have a very important impact in some areas, but not in others. This is why it's important to have this kind of models that you are developing with the stakeholders in Augures to understand the context-specific situation. And from these involve all the projects, all the stakeholders, and identify an holistic approach. Thank you.
Thank you so much, Federica. I'll just pass the word again to Malgosia. Just to say there are final panelists. Nicola just couldn't be with us today. So we'll start with the Q&A now.
Well, thank you. Thank you, all of you. That was a wonderful, sort of very broad overview of initiatives in a number of areas in the EU, FAO, and collaboration with the EU and in Greece. I would like, so we now have some time for questions to the speakers. I'm debating whether to start out with a question of my own, but I think I would rather open it up to the audience and hear what you all want to learn more about. So please, anybody have any questions?
Yes, it works. I just wanted to know that I think there was a question for Nicola in the chat, which asked about if it was possible to make available the resilience index that you were talking about.
Yes, on the farm resilient index, right?
Yes.
Yeah, okay. Yes, it's in the common agricultural policy, we have three types of indicators: the impact indicator, result indicator, and output indicator. So the impact indicators are basically the indicators that contextualize the situations or an issue or a topic, and at European level, and and then we were struggling to find a way to have information on resilience, and the way we tried to figure it out is that we look at the components that makes resilience resilient and farming sector, and we are developing this indicator that from the time being are only using the components for which we have data, and basically we are summarizing the trend in terms of soil organic carbon, and then we have data at European level from the GRC Lucas survey, where they have an average value of soil organic carbon in for member states. Of course, you know better than me that doesn't really help a lot, but this is a starting point for us. Then we have another indicator which is called the WAY Plus Water Exploitation Index, and then with the time with the European environmental agencies, we are refining it more and more, and then to focus more really on agricultural sector or to seasonal availability of water. Basically, it tells you if water reservoirs are under stress or not, thanks to the because of the use of water for agriculture. This is another component. Another component that we are using so far is the variability in production. So basically, we compare the variability of some crops in terms of production compared to a reference period. So the higher is the variability in terms of productions in the different member states, the more we assume that the system is less resilient to climate change. And another component is also the income, an income factor. Also there in terms of we comparing the variability of the income to a reference period. So there are a lot of caveats, as you can imagine, in using all these components, because they are simply proxy. And then we put them together, we standardize them, we try to have an index in terms of a trend in the resilience and also in terms of status. Yeah, I think in a couple of months we will publish the first version in the agricultural data portal, and there you will find where there are a lot of data. There you will find also all the details on how it's been calculated. And if there is some specific interest at technical level, I can put you in contact with the responsible colleague in the GRC, who developed really all the calculations and everything. Thank you.
Thank you for that. Yeah, I think the question was whether that index can be made available, and I think you just answered that to say that it'll be on the portal in, sorry, it was in a matter of months, did you say?
Yeah, it's the Agri portal. We are basically building the infrastructure. I mean, you just need to link it. We have a meeting actually on this Friday between GRC and the ER in Agri, and I think in 1 month it will be there in the Agri data portal, where there are a lot of also the other impact indicators. But I can share with you the link of the Agri data portal. I think before the end of the year for sure. It depends on technical level. If it is easy, it's going to be easy or not.
Thank you for that. So I will start out with a question then, a sort of broad one to all the speakers. You've shared a lot of information, the sort of overview of the both policies that are being undertaken and some of the associated climate information needs. I wonder if you can go through, if you can prioritize a little bit for us, and if each one of you could focus on an example that you think is particularly, that in your area of the area that you're focusing on is particularly salient, where there is a need, where there is an obstacle that is posed by lack of climate information. There is progress that you or people you have been working with want to make on a specific policy or intervention, and that progress has been blocked by lack of climate information and what that information would be. Whoever wants to start?
I think that the problem is not the lack of information. For example, what I forgot to mention is that at the framework of adapting GR, we are also implementing a hub, which includes climatic projections produced by our partners for the project. It gives good practice, examples of good practices and so on. So I think that, coming to your question, that there are a lot of informations and a lot of data spread around that they are not, at least according to my view, they are not analyzed, or they are not clearly described, clearly shown to, and when it comes to farmers, in a way, how they could implement this data, how they could implement all this information that they are receiving from, and the problem is that they receive a lot of information from different angles. And sometimes these informations, they are overlapping. So we have one information from, let's say, from NECCA, one information from universities or from Columbia, one information from FAO, but all these informations target towards the same directions, adaptation, resilience, having a holistic solutions, for a holistic solution. But at the end of the day, we don't get a holistic solution. Like farmers, they don't get it. So I don't know. Somebody else wants to be available.
Just to integrate your intervention, your answer. Yes, in some cases, for example, at the government level, sometimes in developing countries, there is the capability, there is not capability to collect data. There is not a system to collect data. And if there is a system, there is not capability to analyze this data, to extrapolate data and identify the good solutions. So at the farmers level, they have many inputs, not only by international organizations, but from universities, but also from governments sometimes. They have input by the Ministry of Environment or from the Ministry of Agriculture, and they don't have the capability to elaborate a strategy. This is why it's important also to create an approach that involves all the stakeholders. In the system at the government level, if we have a system to collect data, the two ministries involved, for example, Ministry of Environment, Ministry of Agriculture, they have to speak each other. They have to integrate their tools. And also they have to involve in this analysis also the Ministry of Finance, the Ministry of Foreign Affairs, because all in order to receive, for example, financial support from international organizations or from international funds, also or from the governments for a strategy, we need to have this entry point at the international level and in the government, in the Ministry of Finance Finance Affairs. So when we spoke about holistic approach, is easy to say that. It's not easy to apply. And this is why it's important that you have an analysis before and to understand what are the stakeholders that are to be involved in the process. For example, when we have the NDCs now has to be implemented, you know, how to do it. I mean, we need finance support, we need strategies, we need everything. And some government doesn't have this capability. This is why it's important to support them from universities, from international organizations, at the financial level, to develop a good strategy.
Thank you. And Nicola, I'm going to ask you in a minute, but just to paraphrase, if I understand correctly what the both of you have been saying, the need that you're articulating is not only new research, but research that's well coordinated across the different actors and focused on a set of decisions that need to be informed at the end of the day to make sure that there is a line from the university where the research is happening all the way to knowing what the farmer is supposed to do at the end of the day in the field. Yes. Yes.
Straight line and the storytelling. And easy storytelling.
And social aspect is also important when we talk about farmers. What is the situation of farmers? I mean, the story of farmers, is a family farmer, a small farmer, a big farmer, if why they produce this kind of product. Why? Because there is a cultural heritage behind, because they want to increase just their business, or because there is something, this social aspect. So also this is important because when we analyze data, we think, okay, we analyze data, but sometimes it's very cold, this kind of aspect, and we need to insert something hot that is warm than in the social aspect.
Thank you for that. And Nicola, if I could.
And I was hearing also storytelling. It's kind of
Yeah.
Yes.
To say, to give the analysis, the message, yes, to give the analysis, the message based on strong scientific data. But I know it is hard because when you start analyzing and you want it to be scientifically robust, you need to add all the information. But I think that what it must be the outcome of the project, which is very hard, is to give the outcome in an easy concept, in an easy way to be concept by the final user, by the stakeholder. And you have to first persuade the stakeholder, and of course, the other aspect that we have to take into our account is also that what the outcomes of the scientific project must also talk to the politicians, because they will find a way to implement also this the outcomes of our project, of the scientific projects. So the basic is to have a storytelling that is easy to be spread around, but it is supported by strong scientific data.
It sounds a lot like what we've been striving for in AgMIP.
Yes.
And hopefully making progress. Nicola, if I could follow up with you on this same question. So we've heard mostly the level of farmers, decisions at the level of farmers addressed. Could you provide an example that is particularly salient to you where there is a need for new information or a new approach to creating that information at the level of policymakers?
Yeah, I think on one side I can really echo what colleagues already said in the panel. That's are all very important aspect. And turn of examples. Well, from what is our role of policymakers, and we have also we have to also assess the impact of our policy decisions. So of the measures that are particularly in the common agriculture policy, and if the budget is used in an effective way and efficiently, in a cost-effective way, sorry, and this is always a problem where we are asked to do this kind of assessment for resilience, particularly because of the granularity of data that are missing. Because also you need to a definition of resilience, and at the end, I mean, if you stay in the biophysical resilience aspect of you also include social aspect, economic aspect, and all the difficulty to contextualize this kind of assessment. So from our perspective, the impact assessment of the measures designed by policymakers, it's very challenging, and I think there we still don't have the possibility to make this assessment, because usually they are required. But okay, we know that to increase resilience, you have to go in certain direction. You have to implement some practices, but also because we are policymakers, we also need to report on how these practices are having an impact. Another challenge is the fact that you have different objectives. You want to assess the impact of policy measures towards those objectives, and most of the time, climate mitigation, so emission reduction, carbon sequestration, and adaptation are separated, and it can make sense sometimes on sectors like from industries, energy sector, but not really in the agricultural sector. So there we also struggling in this. communicating the fact that we cannot really separate them in the land sector, in the farming sector. And then very last, it's what I was saying during my presentation, is that we miss sub-sectorial information. We have, for example, also there is a project in GRC which is called Peseta project, where they make a little bit of the assessment of production of few crops for future in the future. But then, for example, if we look, for example, on the livestock sector, we couldn't really find a lot of information on that. And so if we have to plan how to address climate resilience in the livestock sector, particularly in extensive livestock sector, we have a little bit more problems there.
Thank you very much. So not only producing information that can help design those policies or inform decisions, but then actually taking the research a few steps further to assess what the impacts are on the ground, which of those policies or decisions has actually been made effectively, how the information needs to be perhaps realigned to make them more effective.
Hi everyone, my name is Ignacio. I work in the Center for Climate Systems Research at Cone University, working with AgMIP on this project. And just a little brief overview of this section. We'll be doing a deep dive into the integrated modeling for decision support. So we'll be starting with a presentation by Georgios Fragkoulidis, with talking about seasonal forecasts, weather forecast analysis, which leads into the presentation by Jonas Jaegermeyr, with the presentation on crop modeling, which then again leads to a presentation by Roberto Valdivia, who will be presenting on integrated modeling and economic modeling. So like I mentioned earlier, each of these pillars their outputs lead to the modeling exercise for the next presentation. And we'll be looking at a deeper level into that. So I guess without further ado, we're ready to get started. Georgios from the National Observatory of Athens, if you want to start sharing your slides, and we will get started.
Okay, thank you, Nick. Hello from my side. Let me start sharing. Okay, so I will be talking about seasonal weather forecasts for agriculture in Europe. I'm from the Meteo group in the National Observatory of Athens, in the group of Kostas Laouvardos and Vasiliki Kotroni, who are here with us today. And my talk will be on the research we do on seasonal forecasts, but also how we collaborate with the agronomists and the entire consortium of Augures on how to best prepare for climate change, but also extreme seasons, I would say. A few words on what we do. So I'm a meteorologist, physicist by training, and altogether in the Meteo unit, we are a group of around 20 researchers, mainly doing research on meteorology and wildfire. And the goal is, of course, to improve our knowledge on the physical causes and effects of extreme weather. And we are in Greece, and there is a lot of extreme weather, from snow to heat waves to droughts to dust transport. So this has, in a sense, made it necessary for us to cover this whole range of activities and do research on all these kind of events. We also disseminate our results in the Meteo GR page and our social media channels, of course. In the past years, we have also started looking at climatological aspects of the research we do, so monitor the trends in all these respects, etc. Early warning systems, analysis, post-event analysis are also some of the services that come out naturally from our research. Let me start by laying out a bit the topic of seasonal weather forecasts and what it is and what it is not. When we talk about weather forecasts, your daily weather predictions, we want to predict if, for example, it will rain here in Athens in 5 days from now, or what will be the temperature in 5 days from now. When we talk about seasonal weather forecasts, we go a bit broader, and we want to forecast whether the upcoming months or seasons will be warmer, cooler, wetter, drier, etc., than average in a wider region like Southeastern Europe, for example. This is something that we can components that vary more slowly, so we can leverage this predictability and issue these forecasts.
Use this microphone? Sorry.
Maybe.
Can you people hear if we speak without microphones?
Okay.
And online we have a
Online
camera, so you should be able to speak without. Let's try without.
So is it fine for everyone if I speak like that? Okay. So yeah, we try to leverage this predictability that comes from the ocean or the cryosphere elements in our planet that vary more slowly. So it's a totally different research exercise, the seasonal weather forecast from your typical weather forecast. And different people work on that, different model developers, and etc. It's very relevant to our project, Augures, because, of course, the agricultural sector is strongly dependent on weather. The crop models that we'll hear about in the next speech are driven by weather and climate. So a collaboration between us and agronomists is paramount, I would say. And this is where the Augures project comes into play and helps us in that respect. And then what's the connection with climate change, seasonal forecasts and climate change? It seems different, but at the end of the day, we want to prepare, farmers want to prepare for adverse weather scenarios, be it an extreme season or a different climate in 10 to 20 years from now. So at the moment, climate models predict that, for example, for Southern Europe, we'll have a warmer and drier future. Having said that, we will have warmer and drier years before the future arrives, before 2100. So working on these interannual timescales helps us better shape our framework, the Augures framework that goes from weather modeling to decision making in the farm level. But it's also a nice research exercise because it helps us verify the models in a more fast track mode than just waiting for future to come. So I sketched a bit what's the role that we play in the project. More specifically, we retrieve seasonal forecasts that are issued from 8 weather centers across the globe, so leading weather centers across the globe. And basically, we want to distill these raw forecasts and compute key meteorological indices, and most importantly, quantify the uncertainty that is there. So we talk about seasonal forecasts. It's very hard to predict what the next season will be like. So unfortunately, we need to talk about it in a probabilistic sense. We cannot say that the coming winter will be 1.2 degrees warmer than average. We have to communicate this information with probabilities. And you'll see about that in the next slides. On a monthly basis, we issue some weather outlooks for Europe based on these forecasts, just short documents about what's to come. And last but not least, we provide the data for the crop models in following the instructions of the agronomists, of course. So that's some technical info. The one thing that I want you to keep from that is that we collect seasonal forecasts from 8 different models, that each of them have around 50 scenarios for the coming season. So altogether, we have 300 to 400 scenarios for the coming season. The models are not the same, and this is good. So we have some range of possibilities. Each of them have different components, and they follow different architectures on how they want to model the Earth system, basically. Let's start with an example. I'll show you some maps. We go back to May of this year and to look at the forecasts for the July, for past July. You'll see eight figures, 8 maps of Europe, and plotted is the temperature anomaly. So the deviation from the usual temperature for each region. So when you see a lot of red, it means that July is predicted to be warmer, 1 to 2 degrees warmer than average. And when you see blue, the prediction says that it will be cooler than average. Each plot corresponds to a different model. So you don't see the same picture in every one of them, but the big picture is that we'll have a warm July, and if you spot it, maybe Southeastern Europe will see a warmer than the rest regions. Now we want to combine all this information to one multi-model. So here you see the average of these 8 panels. And studies have shown that if you combine all the available models, then you get a better result on average. So you see here that Greece, the Balkans, Spain, and Italy are predicted to have a very warm July ahead. But that's just the mean picture. So of all the scenarios that I said before that we have, this is just the mean picture. And it's wrong to stay there and go out to the public and say that, well, for North Greece, we predict that it's going to be 1.3 degrees warmer than average. There is a lot more information out there to be leveraged. So we have to go beyond these means and look at the whole range of scenarios. On the right, you see an example of our monthly bulletin in the Meteo GR page, looking for the month ahead. And you see that on the x-axis, you have again the temperature deviation, and on the y-axis, you see the probability. So it's just a typical histogram. And you see that most of these scenarios are showing warmer conditions than average. I would say the most probable scenario would be that we are between 1 and 2 degrees above average. So this is the whole ensemble that is there, 350 scenarios. They boil down to these probabilities. The point now is that we have to communicate this information somehow in an actionable manner for the agricultural sector, but also for the whole society. One way to do that is to take the distribution of this ensemble that you saw and split it into 3 categories. One category is average temperatures, and another category is the cold temperatures, and the other one is the warm temperatures. And we want to communicate how probable it is to have a warmer than average month, a cooler than average month, or an average month. So these 3 probabilities, so we boil it down to 3 numbers that we believe are giving a good picture of what's to come. And we can use the IPCC language for that because I find it well thought. So let's say we have some numbers like 60, 32%, 13%. There are some businesses that can incorporate these numbers into sophisticated models and assess the risk. But for the broader public, you maybe want to translate these numbers into phrases to verbally say that it's likely that we have a warmer month, it's unlikely that we have a cold month, etc. So let's go back to the July forecasts. On the left-hand side, you see the probability to have a warm July. It is a map, and the color you probably don't see that, but it goes from 0 to 100. It's the probability to have a warm July for each dot in the map. You'll see that this probability is raised in Southeastern Europe. It's not so much in Northern Europe. On the right-hand side, you have the probability to have a cold July. And you'll see that it's almost everywhere unlikely to have a cold July. So if you translate it into words, it's actually very unlikely to have a cold July in Southeastern Europe, whereas it's likely to have a warm July in Southeastern Europe. Okay, so what actually happened in July? It was actually the warmest July on record for Greece and other countries in the region. You'll see on the left-hand side observations, basically, based on the ECMWF analysis. A big area of Southeastern Europe was indeed a lot warmer than average. So we can say that for that region, we had a good forecast, a good seasonal forecast 2 months ahead. For Northwestern Europe, the forecast was bad. So we were predicting warmer than average temperatures, but they were actually average or even colder than average. In our background research, we systematically evaluate the skill of these forecasts, and we'll have results published early next year, hopefully. It is the skill that we have, and we have to communicate this skill as well, I think. So we have to go to the farmer and say, that's the forecast for next season, and that's the skill of the model. So you should not, nobody should pretend that this is what's going to happen. Actually, there is some uncertainty and some errors that systematically happened in the past. We can compute other meteorological indices like the amount of warm days that we expect, again, for July. Maybe some stakeholders want to know, okay, the month will be 1.5 degrees warmer, but how many days will be hot actually within this month? And this is actually something that we can compute, or we could compute the frost days. What I have here is the latest forecast that was issued a few days ago for the coming December. We see here that it's very unlikely to have many frost days in this December. So that's another piece of information that may be useful for some parties. And to finalize this, of course, we then work closely with the agronomists, and we want to pass the torch to them, the information that they request for the crop models to run is given to them, and the whole range of possibilities. Yeah, then we don't just, the goal is not to just go to the farmer and say this is the weather forecast, but also to provide crop information actually. So thank you very much. I'm happy to answer any questions.
Thank you, Georgios. Fantastic presentation. Forgot to mention, we have a little bit of time after each presentation for any burning questions related to that presentation, but then at the end, we'll have time for a large Q&A. So that being said, is there any questions for Georgios for this particular presentation? All right, I think we can move on to the next presentation.
There's a question here. Nick?
Yeah.
Where?
Oh, yeah.
I can ask it later.
If you want us to know, go ahead.
I'm sorry.
It's very basic. Don't worry, I can speak loud. I have a hearing problem, so I speak loud.
I'll repeat it.
We can repeat it.
Yeah.
It's a very basic question, and this question applies practically to all kinds of models. Have you done any real validation on the predictions, site-specific validation?
Yes, that's the research that we do.
So can we repeat the question for live?
Oh,
Just
yes.
so
The
simple.
question is if there has been any validation in these seasonal forecasts, actually. And we do research on that. We have computed the skill of these forecasts and how they performed in the past 25 years. So taking the modern models and looking at how they would behave if we rerun the past 20 to 30 years. The skill is, so there is some skill, so it's better than guessing. So it's better than random forecasts of the months to come, but it's not great. So we cannot really, we are not in a position to have a 100% success in the prediction of the coming months. It's a physically very hard problem. There is chaos in the atmosphere, and sometimes it overshadows any predictable signals that are out there. So if I can give you a number, I would say that the skill is a bit better in summer for Southeastern Europe. So there is some skill, and this skill is about 50 to 60%. So in 50 to 60% of the times, we predict the correct temperature anomaly category. So we talk about these types of skill at the moment, but within Augures, the important thing is that we construct the framework and we have it there up and running with the possibility that at some day this skill will get better as well. Yeah.
Thank you, George. I will ask you the grades.
Yes. Yeah. Thank you.
Thank you.
All right. Yeah.
A quick follow-up. So you told us about 2-month forecast with a 2-month lead. Is that, do you pick the 2 months for us?
It's just the example that I showed.
Okay,
Yeah.
so there can be there is
Yeah.
still in other lead times?
Yeah, these seasonal forecasts go out to 6-7 months. And the scale, of course, gradually decays as you go further ahead. But there is still some skill until month 5 or 6. We are still better than random forecasts on that time frames as well.
All right.
Yes.
Oh.
Another question.
And the shorter time for forecasting is
I mean, you mean the shortest that you can get from these seasonal forecasts? I would say 1 month. If you want something for the nearer future, you would look at typical weather forecasts or what they call extended weather forecasts. So these are forecasts that go out to 1 month. And you would go to seasonal forecast when you want to see 2 to 6 months ahead, I would say.
Yeah, because it's an important information for the farmer. If he or she wants
somehow modify the calculation management program, showing yields.
Yeah.
If you are talking about any warning systems, it would be the.
Yeah, of course, if there is like a strong weather system approaching, we talk about weather forecasts and early warning systems on these 5 to 10 day timescales. The aim of seasonal forecasts is to give like a broad overview of the average weather that is to come in the next months. You cannot issue an alert or something. You can just raise awareness that a warm season is approaching or something like that.
All right, let's move on to the next presentation, and any other questions, feel free to ask at the end. Next, Jonas from AgMIP will be presenting on crop modeling, and yeah, the floor is yours.
All right, great. My name is Jonas Jaegermeyr. I'm with Columbia University and NASA, Goddard Institute for Space Studies in New York City. And again, I encourage everybody to join the Zoom meeting and look at this, the slides on your screen, because I realize it's very far away from those sitting in the back. It's much easier to follow the presentation on your computer. What I'm going to do is introduce what we are doing in other projects more globally, the approach of AgMIP and the crop modeling itself, and then try to explain what a crop model is, and then sketch out some first results that we have for this specific project and how results can be meaningful and helpful. And that's ideally interactive. So I'm also asking the room to respond to what would you like to see and hear that would make your life easier. So we present a couple of ideas, but this is from the global modeling perspective, and we really need to hear from everybody what's helpful in this regard. Yeah, you heard of AgMIP, the Agricultural Model Improvement into Comparison Project. That's a mouthful of an acronym, but it's a lot of it has some traction. It's a lot of folks interested in climate change and agriculture and modeling, and we have a whole suite of initiatives, from global crop modeling to economic integrated assessment modeling, to highlight those two that are represented here today, and then various other initiatives that we can't go into detail here. But I'm going to represent the global crop modeling, or I do lead the global crop modeling in AgMIP with a partner in Germany, and explain a little bit along those lines. And then Roberto Valdivia is going to go into the integrated assessment modeling and the economic modeling. Part of this is then in turn actually feeding yet into another MIP. So MIP is a model intercomparison project. And that's important because all of what we're doing here is we're translating climate information into climate impact information, or climate impact science. What does it mean to society if climate is changing? And we need MIPs to reduce uncertainty. Everything related to modeling, especially to impact modeling, is associated with large amount of uncertainties. And if we employ not just a single model, but a whole suite of models that do the same thing, just a slightly different way, then we have a better understanding of at least our known uncertainties. There's also unknown uncertainties. So in AgMIP, we do the agricultural world, and then in ECMIP, that's based at the Potsdam Institute for Climate Impact Research in Germany, we put those agricultural information in context with other impact sectors, including human health, energy, water, and so forth. So we have a broader spectrum of how climate change potentially affects society. So this is to give you a broader context of where we're coming from. Here's an example for the type of work we usually provide. This is a multi-model ensemble result 12 crop models, each driven by 5 global climate models running for different climate scenarios and to different crops over the course of the century under a high emission scenario. And obviously we represent the every breadbasket of the world for different crops. And you immediately start seeing that it really matters where you are and what type of crop you are growing. The response to climate change is going to be very different. At the same time, we can be very local if we wanted to. The models itself can be set up and calibrated for a hyper-local situation. It's really the inputs, the climate data, the management data, and so forth that limit the spatial scale and scope of the model. And here's an example for a high resolution setup in Iowa, maize and soybean rotation, where we can really represent each individual field as we go through the years and track what has happened. Usually we work on those major commodity crops, wheat, maize, rice, and soybean, but that's not the end of the story. It is really important to represent crops that are locally relevant. So a recent initiative is to expand the number of crops we can represent. So this is an ongoing project, or a just finished project that we engaged in, where we tried to set up a crop model for a whole list of additional crops. Some of them you haven't heard of, finger millet and teff and cowpea and all those crops that are actually really relevant on the ground in parts of Africa, but we often overlook when it comes to larger trade commodities. Now let's switch gears and ask the question, what is a crop model? We're setting up these process-based or mechanistic models that represent our understanding of biophysical processes to help decision making. And there's basically 2 input aspects. There's weather that drives what's happening on the ground in the field. It's temperature, precipitation, radiation, and also the CO2 concentration, because carbon dioxide in the atmosphere is really important for crops. And management. Management is, in fact, often the bottleneck, because we have some sort of idea what the climate is or the weather is, but we often don't know what the management on the ground is. So things like planting dates. What kind of cultivars or varieties are you actually planting? How much and when do you apply fertilizer? Is it under irrigation or rain-fed? Where do you actually situate your field? And then very importantly, what's the crop, the soil profile going to look like? Those questions really determine the outcome of the model. And there's the phrase that every modeler knows, garbage in, garbage out. So if you don't have quality input data, don't expect quality outputs. And then we are very concerned with evaluation, benchmarking, and improvement. So there's always an internal cycle of calibrating the models and improving them. And as I mentioned, our goal and mandate really is to create multi-model ensembles. So we usually try to use multiple approaches in parallel to get to the to at least quantify a little bit of these uncertainty ranges. Now, everything I'm saying here is in context of process-based modeling or mechanistic modeling. And I bet not everybody of you is aware of the difference to say an empirical model or a regression model, which is a much simpler approach, which has its own value and strength. It's easy and fast and can often get to things that you can't represent necessarily in a process-based approach. But it's not the right tool to, example, look at a far out of sample future, 50 years out in the future. A regression model just can't get to those changes in a good way. So think of it like this. This is the difference between a process-based model and an empirical model. We try to represent everything you could potentially know of what's happening in the ground. The sunlight is absorbed, where the crop water is infiltrating, its carbon is allocated to everything you can potentially put in there is in the model, which makes it very complicated. Now, where do we go with this? Why do we do it? And we basically have 3 different stakeholder groups here. Number one is impact assessment and finding adaptation pathways and attribute climate change. So we're trying to understand what climate change does to global agriculture. And then there is a downstream application of economic models. We want to understand how would those changes in productivity propagate to changes in trade pattern and prices and so forth. And Roberto is going to speak to that. And then one avenue that we're going to highlight here is seasonal forecasting. Okay, so our lead time is not going to be 50 years, but really what's happening at the end of the season, and can we create added value? Can we create information that can feed into an early warning system that is indeed helpful to the farmer or an insurance company on the ground? Let's understand real quick how we would approach a seasonal forecasting from a modeling perspective. We just heard from Georgios about the likelihood of June being warmer. That doesn't help us. The crop model doesn't care of the likelihood of June being warmer. We need a quantitative specific information for the whole season, because the crop model starts in the beginning of the year and then runs until the end of the year. And whatever we give the model in terms of weather information, it gives us an output. So we need to construct a climatology starting from an actual weather record for the time being. And then there's a forecast day when we decide today we want to know what's happening over the course of the next couple of months. And then we can piece together, say, a numerical weather forecast, which is usually about 2 weeks. And then we leverage seasonal forecasting that Georgios just introduced. And then often we have to finish the season with some sort of historical climatology, because the skill in seasonal forecast peters out or is simply not available. So all of that is what we call the lead time. And that can range, to your question, from a week or two to more than a year. We can extend that lead time for the next season, but don't expect a great skill in the forecast, right? So, and in this setup, we're employing the ERA 5 reanalysis product. That's an observational modeling product that ingests all the observations, and then pair it with a long-range seasonal forecast from ECMWF to create this whole climatology that we then use to run in the crop models and evaluate what's happening. This is a little bit of a question into the room. So this is a sketch of how can a forecast be helpful? What do we expect from it? And this is just where we're coming from. You know, hopefully it can assist in planning and farm management. If we were in a perfect future, if we were in a place to have a forecast with skill before planting, then we can actually change what type of crop we're planting, what type of cultivar we're using, where we're planting it, but we're not quite there yet. But there's additional farm management that you can do mid-season based on such forecast. And part of this is an early warning of extreme events, irrigation infrastructure and scheduling. So you can move around some of the infrastructure for irrigation, but you can also time your water accordingly if you have a rough idea when a dry spell is occurring. Important is harvest timing and storage planning in view of commodity markets, but also, you know, if the forecast is saying this is a particularly dry September, you're more relaxed about the corn or maize harvest. Whereas if you see a more a wetter September just before harvest, farmers get really concerned about the grain humidity. And then the insurance market and commodity trading are just put it on the list, but there's additional aspects that I would love to discuss. And again, this is something I would like to hear from. What type of products can we provide? The number one aspect is yield at harvest or productivity. So we try to get an early estimate of this season's productivity of a specific crop. But along with that, we can look at irrigation water requirements. How much water does a crop need to go through the season? And then harvest time. Do we expect it to be an early harvest or late harvest? That's mainly temperature driven, but is really important in context of commodity markets. One side aspect is fertilizer application amount and timing. That's very farming system specific, and it's difficult to give recommendations from a higher top-down level, but that's in theory also something we could get to. I would like to now dive in a little bit and give you a flavor of how we work and how we look at things. Here's part of what Georgios said. Here's the ERA5 reanalysis, maximum temperature for a specific day in April 1st. That's where we start our forecasting for the season. And we could simply compare it to the forecast model. So on the left is an observational based product, and on the right is a forecast model. And they look very similar. The overall pattern match, and the colors seem to be aligned fairly well. But if you look into detail, for example, the arch of the Alps, they mostly disappear in the forecast. And that's because it's washing out. We lose spatial detail because the model can represent it's at a higher spatial resolution, but it also can account for those spatial details in the same way. So we're losing detail that we will then also lose in the models. And if the weather input doesn't give you the specific heat days or the maximum temperature, don't expect that those responses are reflected in the model. So this is something we need to understand from the very beginning, that a forecasting model doesn't have the full truth, or we can't expect it to represent reality in the way we want. Now we can look at precipitation, one of the most important drivers of crop growth in the region, unless it's irrigated, obviously. Just going through the season, different forecasts initiated in April and in May, in June, July, August. And this is a relative era map. Nick produced those neat maps that show the difference to of the total precipitation amount over the season from April through October as a difference to the final observed amount. And in April, there's a lot of brown and blue, which means we're pretty far off from the actual observation. And then as we go through the season, the forecasting, the lead time becomes shorter and shorter. So the colors get more muted, and you see more white and light colors, which means the errors get smaller and smaller. So if we initialize our forecast later in the season, intuitively, we can expect a better scale. And then finally, this is the observed total amount. And I think, yeah, I circled there. Okay, bear with me. One technical slide. Don't worry if not all of this is clear, but this is an example from Iowa in maize in 2012, where we set up such a forecasting system and went through the season. It's too small for you in the back of the room to read it. At the x-axis, we have the forecast day starting at day 120, and these little orange bars are basically our error range of what we can expect the yield to look like at the end of the season. And if we start in the beginning of the season, we don't really have much forecast data available. So it's basically a reflection of historical climatology. Where did yields range historically over the last years? And that's, doesn't give you a whole lot of information. But as we go through the season, we update the system, in this case, actually every day. We would rerun the system with incoming weather forecasts and additional data. And we see the curve to move a little bit. It inches down. And then we employ additional data. We use satellite data mid-season to recalibrate the system and start from a different baseline. We say, oh, this season looks actually pretty good. NDVI remote sensing data indicates an above average crop growth. We factor that into the system, update it and rerun it again. And over the season, we're approaching the actual observed yield, which is the horizontal line, and even undershoot a little bit and then come back. So there's two questions we're asking with the system. One is, can we increase the lead time? Can we push back that little approximation curve back in time and have it maybe more than a month, maybe 2 months or 3 ideally? And then also we want to reduce our model error. In this case, it meets the observational data very, very well, but it's not always the case. So sometimes the model actually is off even with observational data. So this is just an example how we expect the results to look like in this case, in this project. And I want to finish off with a quick case study, early results that we created for this project in the Pharsala region in Greece, one of the agricultural hotspots. And then I included a map here, and this red box is approximately the size of a grid cell of the weather data, and accordingly the crop model. So a half degree, which is very coarse, and you can imagine that trying to represent the whole system, which is here a snapshot from Google Maps with all these small scale, for US standards, small scale farms scattered around. When you try to represent that with one grid cell, you have a lot of mixed pixels and averaging effects. So that's always going to be a challenge. So this is the modeling results for that region. And we initialize our model in April, starting through the season with the forecast provided by Georgios. And as we go through the season, it's exactly happening what we saw on this on the slide for Iowa before. We're first shooting above the expected yield and then undercutting a little bit, but then soon after we start approaching the expected yield based on observational data. In yellow, that's the rain-fed results for maize, and in green, that's the irrigated component. We always run an irrigated component just for reference. And this is not calibrated yet, so don't get too hung up on the actual numbers of the yield. So they're too high for this region. The observed numbers in that region are about 1.5 tons per hectare and not 3 to 4 tons per hectare. So the system will be calibrated and includes observational data more. But the idea is clear that in the beginning, where our estimate is far off, and then as we come closer, we are approximating the results better. Now you can say, oh, in April, the forecast is actually not too bad. We're quite in line with what's observed eventually. But that's just one example. So if you go to another year, here for 2019, you see that the initial estimate is actually not that good. And as we go through the season, we learn that the season is actually much better than initially thought. So the lead time, the skill increases with a shorter lead time dramatically. And another year, 2020. In conclusion, based on these very preliminary results that are not calibrated and fine-tuned, it supports our hypothesis that a lead time of about 1 to 2 months seems to be appropriate. Harvest in this region is about mid-September-ish. So the August, the last data point on these graphs, has a lead time of about 2 months. The July, about 3 months. So that's the range, that's the skill that we think is going to be reasonable. But again, we have to corroborate that and include additional models in wider regions. So in conclusion, we see a lead time of around 2 months. That's what we expected prior to this project. We need to calibrate it, and we need to leverage local management data. So for now, we don't really have fine-tuned information on when people plant and what kind of cultivars they're using. So this is a conversation we need to have and include. And then obviously we will rerun the model for the whole country and have a much better representation of what's going on. The results I showed are only based on one ensemble member, and ECMWF provides us with 51 ensemble members. So once we run this 51 times, we can actually create little error bars around these dots. So we have a much more, a better, more robust approach to those numbers. And then eventually we will also do this analysis for wheat. This is the Augures first year, outlook, and then we're talking about a phase 2 potentially where we would add additional crops, we would expand to additional countries, and very importantly also add a long-term climate change impact assessment to complement these seasonal outlooks. All right, I hope this wasn't too technical. Please ask, and if there are questions, and let's discuss.
Thank you.
Yeah, any burning questions in the room for Jonas? Keep in mind that we have one more presentation and then we can have a larger Q&A afterwards. All right, great. Well, in the interest of time, Roberto, if you want to come up, and Roberto will be presenting on the economic modeling and kind of the holistic integrated approach across these 3 sectors. Roberto, the floor is yours.
Thank you. Okay. Yes. All right. So my presentation is about first giving an overview of what in AgMIP we call regional integrated assessment, and then how we can apply this approach to the Augures project. A little bit of the economic modeling that we do within this regional integrated assessment approach. And then at the end, a few slides about possible applications within the Augures project in the future. So Jonas already presented what is AgMIP. I guess first to start with some key questions is, how can we do meaningful analysis of agricultural systems, looking at the impacts of agricultural policies, technology adoption, climate change, adaptation, mitigation, and how can we communicate this type of analysis to decision makers? You see that I have highlighted the more meaningful. So what is meaningful? And stakeholders want to know the impacts they care about, right? Like poverty, food security, health, environment. It is not just about yields or aggregate production, but we know that yields play a key role, right? It can drive poverty, can drive food security, but at the end, the stakeholders have a set of outcomes that they care about. So what to do, what it will cost? It's what I think was your name Antigoni was saying. We need a holistic approach, right? We need to involve all the key actors: farmers, crop leaders, farm advisors, research managers, policymakers, private sector scientists, to work together on this. So with this in mind, many years ago, we started working in AgMIP in Africa, and we developed, the mission of AgMIP. I think that's important. Is to provide effective science-based agricultural decision-making models and assessments of climate variability and change, and sustainable farming systems to achieve local to global food security. And we've been working already many years to improving and implementing agricultural models in different regions of the world. And one of the things that we have done is to develop what we call, as I said, the regional integrated assessment, which is a protocol-based approach that links or integrates climate data, crop, livestock models, and economics together to be able to evaluate different sets of scenarios under current conditions or future conditions to see how they can impact biophysical outcomes or socioeconomic or environmental outcomes. And we do this at different scales. We started working on this project many years ago, involving 18 countries between Sub-Saharan Africa and South Asia. What is important about this approach is that it's, first of all, it's stakeholder driven. It includes the whole farm, because even though sometimes we focus on a specific crop, but we know that farmers grow other crops, they have other activities, they have livestock, right? So we need to have a whole farm approach. It's transdisciplinary, it's multi-scaled. We use, as Jonas was saying, we try to use multiple models. And the other important thing is that we can estimate distributional impacts, for example, poverty rates, and we'll talk more about that in a little bit. So the way that we usually work in the sequence in AgMIP is first trying to learn the current conditions or what has happened in the past in a specific region. Then we use our models to assess we're talking about climate change, the risks of the agricultural systems. And then we discuss with the stakeholders, what is the vision to the future? What are the possible scenarios that the farming systems will look like, I don't know, in 2030 or 2050, we are projecting out in the future. So we develop these, what we call future socio-economic scenarios. We also work with the stakeholders to develop or design adaptation and mitigation packages that the stakeholders would like to test in a specific region for a context-specific cases. Then we use again our models to evaluate the impacts and discuss again with the stakeholders. And we also have what we call AgMIP Impact Explorer. It's an online dashboard where we present our results that is available to the public. So that's kind of the sequence of the regional integrated assessments. Now, let's talk about the economic model that we use within that framework. It's called the trade-off analysis for multidimensional impact assessment, or TOA-MD. It's a model that we use for impact assessment that uses a statistical description of heterogeneous farm population to simulate adoption and impacts. Could be of a new technology. For example, if we want to propose a new crop variety or change in the crop management, change in environmental conditions like climate change, or policy interventions like payments for ecosystem services, for example, right? It's not a farm level model. It's a model that treats a population of farms. So we estimate distributions of outcomes like net returns on a population of farms. And this is important, and I'll mention that in a little bit, why. So the model is designed to simulate what we call experiments for a population of farms using what we call a base system or system one, that, for example, is the current conditions, how farmers operate in the current time. And then an alternative system, system two, in the case of the example of adopting a new crop variety. The idea is to characterize the farming system. What would happen if farmers would be using this new crop variety, right? So the traditional analysis, if we, in this figure, if we think about this outcome, for example, net returns or farm income, and with the old variety, we have this E1 as outcome or net returns. And with the new system, with the new crop variety, we get E2. With the traditional analysis, the representative farm or the average, using average data, we can estimate those changes, but we cannot model adoption rates or distribution of impacts. Why? Because in a population of farms in a region, farmers may have different biophysical conditions, socioeconomic conditions, right? They could be in a place where the soils are better than other farmers, or even just neighbors. They manage their farms in a different way. They use more fertilizer, less fertilizers. In other words, the response to a change is different across farmers in a population in a region. So the TOMD model tries to characterize that population of farms to estimate these distributions so we can model what is the potential in this example, what's the potential adoption rate, and who are the adopters and who are not the adopters of this new technology. In the same way, we're talking about climate change. Not everybody is impacted the same way, right? So there could be gainers and losers to climate change. So with this approach, we're able to estimate or see what are the gains and losses due to climate change. So how do we do this integrated assessment? I'm not going to go in detail, but it's basically just going from climate data to biophysical data, the crop models, using scenarios, socioeconomic, biophysical scenarios, and more importantly is, of course, all the data that we need, right? We need data on crop yields, but what is more important is management. That's something, as Jonas was saying, that's something that it's very difficult to get. And for us, for economists, a key part of the data that is being challenging is cost of production. Many surveys, they collect data on outputs, like production prices or revenues or profits, but not detailed cost of production. And that's important to have. So we need to think about how we deal with this lack of data. So then with the model, we produce our outputs. And as I said, look at adopters or non-adopters in the case of technology adoption, or gainers or losers in the case of climate change. But this is all part of our stakeholder-driven approach, right? At all these stages, we work with the stakeholders, defining the scenarios, defining the key indicators that they care about, and defining the technologies, strategies, or policies that they would like to test. Right? So for this project, I just did a very simple scenario just to show the kind of outputs we usually get with this modeling approach. And so we are focusing on maize and wheat-based farms. I borrowed this map from this publication, and discussing with Dimitri Lalas, who's online, he told me, well, these are the regions in Greece where basically 95% of the production of maize and wheat are basically produced. So we try to focus on those regions. However, again, lack of data, especially cost of production, so far has limited the analysis that we could do. So we look at the historical data, and here I have a question for you, because the maize yield reported by FAO Stat is much higher than the ones that you have. It's about 10,000 to 12,000 kgs per hectare, but we can talk about it later. And so we focus on maize and wheat yields. There has been a little bit of increase over the years, but not much, almost stable. So what we did is we selected three types of farms. Farms that specialize in grain maize, where the minimum 40% of the output comes from maize. That's one type. The second type of farms is durum wheat, also where 40% of the output comes from durum wheat. And the last one is common wheat. And so when we look at the net returns, the farms that specialize on maize, they have 93% of their income comes from maize production. They have other crops for 4%, and just about 1% between, or 2% between both type of wheat. Now the farms that specialize in wheat, durum, 75% of their income comes from wheat durum, and 14% or 15% from maize, and 7% about other crops, and 3% from common wheat. And likewise, the farms that focus or specialize on common wheat, about 74% of their income comes from that crop, and between 9 and 8% between maize, durum wheat, and other crops. So that's kind of how these type of farms have the share of net returns to the different activities. So what I did was looking at two scenarios. First scenario, what we call the base system, is looking at what is the average production or yields within that period of time of data that we got. Let's call it a normal year, kind of the average across all these years. And then the alternative system, we chose 1 year that had lower yields. We can call it a bad year. And the scenario 2 is the same average yield. And then the alternative system is one where a year that has higher yields. Let's call it a good year. So we estimated what we call relative yields, which is the change with respect to the base yields. So in the scenario 1, for maize, there is a decrease of about 5% of yields. For wheat, 15% decrease. For durum wheat, and for common wheat, about 9%. In the scenario 2, which is what we're calling good year, there is a 4% increase on maize, 20% on durum wheat, and 11% on common wheat. So as you can see, the changes in maize are small. Durum wheat probably is the one that has more variability in terms of the changes. So let me move to the next one. Some preliminary results. Let me explain this figure. So we have the first part on the top is the L, the low or the bad year. So we have the maize farms, durum wheat farms, and the common wheat farms, right? And the bottom part is a good year. So we have 3 indicators. One is the proportion of households that are vulnerable, the change in mean farm net returns, and the change in poverty rate. So let me explain this. The proportion of households that are vulnerable, it's basically the proportion of farms that are at risk of losing income or seeing their income being reduced because of the changes in the farm. So for the bad year, farms can lose between 56% or 57% in the maize and durum wheat, but up to 75% of their income in the common wheat. So they are the ones who suffer the most. In the good year, even though still there are farms, or still in average, there is an increase in yields, because this heterogeneity, there are still farms that are vulnerable. About 40%, 42% of farms that could lose because these conditions. So, and this is reflected in the change of farm net returns, right? So on the top, you see, for example, the common wheat, that 75% of the farms are at risk of losing. Those are the ones that lose the most in terms of the changes of farm net returns. About almost 30% of farm net returns are lost. In the case of the good year, of course, there is some increase in terms of farm net returns, although a little bit small, less than 10%. And income, as you know, it's correlated with poverty rates, right? So again, the example of the common wheat, they have the largest decrease in farm net returns. Hence, they also have the large increase in poverty rates among these farms. Now, the others, well, we can also include other, if we have the data, we can include other socioeconomic, biophysical, environmental outcomes. We can include the changes in food security, in nutrition. We can include gender-specific indicators or environmental indicators like greenhouse gases and others when we have the data. And we can show the trade-offs and synergies among the different indicators. Now let's look at this other figure. And sorry for too many bars, but let's just focus on this one, which is for durum wheat and for the bad year or low yields. So we have three indicators. One is called net economic impacts, and the other one is gains and losses. So if you see the net economic impact, in this case, it's decreasing 10% of the mean farm net return. So there's a loss, right? So this is across all the farms. This is what you would get if you were doing analysis like a benefit cost analysis, right? Kind of that average result that shows what is the average impact. But what a benefit cost analysis doesn't do is looking at that there could be some gainers and there could be some losers from this case, right? And I think that is important because imagine if you are designing your policies based on that average measure, you are missing, right, a segment of the population that could be gaining or losing. And again, this is based on how we characterize these distributional outcomes. If we're looking at the high or the good year, for example, and again, if we look at this average, the net economic impacts is positive. And if we are designing policies based on that average, then we are losing this segment of the population that is losing, right? So that is why this approach is interesting because it allows us to disaggregate these outcomes across the population of farms. Okay, so what is coming next? For Greece, I think the idea is to link the seasonal forecast and the crop modeling with this economic model and see if we can disaggregate across the different regions in Greece. Depending on the data, as I said, we have some challenges with the data. And then for the next phases, hopefully with the Boris project, the idea is to look at assessment, continue with the seasonal forecast, but also looking at assessments of medium and long-term impacts, implementing this AgMIP integrated assessment. And looking at something that I mentioned before, doing these future scenarios, right, which is part of our foresight work that we have, which is what we call representative agricultural pathways. And why is this important? Imagine that we have our farms today, right? We can characterize our farms today. But if we are moving into the future, let's say 2030, 2040, or 2050, we don't know how crop yields would be. We don't know how production costs will be. We don't know how technology will change, or policy institutions, biophysical conditions. We just don't know. And we can put many drivers, right? They could increase, they could stay the same, they could decrease. And those drivers will determine how the future conditions of these farming systems will be. So in AgMIP, we have developed an approach to develop how these future conditions may look like. So these scenarios, we call it pathways, considering global and national trends and using these different trends or drivers, we create narratives, and then we quantify those narratives, and then we use our models to see how the farming system may change under those specific socioeconomic biophysical conditions, right? And we use this with our stakeholders. Let me just quickly move through. AgMIP has four core questions. Okay, I'm gonna go really quickly. So we have four core questions. One is, what is the sensitivity of climate change under current systems? So we look at how climate change may impact the systems as we see it now, right? That's our core question 1. And then the core question 2 is, what if we start adapting now, how the system will respond to that? And then if we think about the future, then we need to translate our systems into the future. That's where we use the RAPs. And then we do the same kind of analysis. What are the impacts of climate change under those future conditions? And what can we do to adapt those systems? I'm just going to really quickly. So we use these RAPs, these scenarios, to link across the scales, looking at national policies and subnational policies, and create different scenarios. In this case, this is an example from NECCA from Zimbabwe. We created 3 different pathways: a sustainable development, a business as usual, and a pathway where the government didn't care about agriculture, basically, or sustainability. Then we can see how this may impact biophysical, socio-economic, and environmental impacts, and then design adaptation and technology interventions. And then, of course, we use this information to talk to stakeholders to design policies, inform the NAPs and the NDCs projects. And the last point is, what is interesting about this approach is, because it's a protocol-based approach, we can replicate and use in different systems, in different places, so we can compare those, right? Because sometimes you have assessments of climate change, but they use different methodologies, different assumptions, and it's difficult to compare. In this case, we can compare apples to apples and look at the whole region. And that's all. Just so you know, at the end of March, we have our 10th AgMIP Global Workshop. It's going to be held in Mexico, hosted by CIMIT, or you are invited. Thank you.
Thank you, Roberto, and thank you all for your presentations. If there's any questions in the room or reactions to how this modeling approach could help your work, or even thoughts about what you think may be included that could help your work, please, either online or in the room.
My question regarding the growth modeling is this does the growth model includes takes into account also the extreme weather events happens for the world in regular days? Do you believe that the growth models also include this kind of information?
Yeah, let me answer.
Can you please repeat just in summary the
Okay,
question?
the question is if the crop models include or respond to extreme events, extreme weather events. Short answer is yes, but so in general, the crop models are known to not be sensitive enough. So if you compare the crop models to observational data during those disasters or extreme weather events, they don't represent those losses or adverse impacts to the same extent it has been observed. And there's a question why. The crop models itself have capacity. They have the processes to respond to extreme heat and drought, and all these processes are in the model. The question is, why aren't they sensitive enough? And then one answer to this is the climate data. We are feeding daily temperature and precipitation into the model, and if the climate or weather data doesn't represent those extreme weather events to the degree they happened, the model can, model the results. But there's also more to it. So we're currently working on advancing those models and represent these effects a little bit better. Short answer is yes, but not to the extent you wanted it to be.
If I may add something, I think that an important point is what the Georgios has already presented, that as far as we have seen in the seasonal forecast, it's quite difficult to forecast at seasonal scale those extreme events. it's easier to forecast that, let's say, long periods of heat waves or higher temperature or drier conditions. But the events like Daniel that you already mentioned cannot be seen in the seasonal forecast.
And flooding is a great example. The crop models are particularly bad at representing flooding, and not just flooding, a broader excess moisture. You know, there's waterlogging from too much water in the field, and then inundation from actual flooding, physical damage to the crop. Those things aren't really represented well by the models. We're currently working on that, but heat and drought are usually both.
Great. Just to summarize a little bit of what we were saying, seasonal forecasts aren't great at capturing short-term extreme weather events. However, they're better at capturing more climatological longer-term events like heat and dryness. Any other questions in the room? Comments? Or anything online in the chat?
Let me turn it around if I may.
Sure.
So we talked a lot about forecasting. What do you all think is helpful? Would it make sense for you to have a 2-month lead on our maize yields will be, 10% lower than average? Or is it the irrigation water requirement? Or is it harvest timing? Or in a perfect world, what would you like to see from such a project that makes your life on the farm or in the field or wherever decision you're making easier?
Would be very nice if these models are becoming a little bit more site specific. And when you simulate the yield of the field, you should consider also the variability of the field. That's where precision agriculture can be linked because when you simulate something, you assume a uniform conditions. I know it's going to be extremely difficult to break down the model and run 10 simulations for one field instead of one. Probably the overall average effect will mask the individual ownership. This is thought.
Yeah. So
really now it's a big issue.
okay, so your issue is spatial detail, spatial
And
resolution.
The difficult component of the system, we are calling them crop simulation. In my opinion, it's wrong. They are mostly based on soil processes. So if the soil component is not working in a model, forget it.
Yeah, fully agree. Yeah.
Can we repeat?
So absolutely.
No, that's helpful. Yeah. So
I'll tell you something in the last. You brought me back 40 years ago when I was working with the best models in the world. 40 years ago, those models were produced. They became commercial available. Farmer was using it. Someone asked me, why this model disappeared? I'm talking specifically about the Gaussian, Gleisian models, simply because these models taught the farmers how to grow better corn, soybean, wheat, etc. And then, all of a sudden, simulation modeling sort of was lost, was overtaken by so much technologies on the precision agriculture that we lost the link between this. So we should think about bringing back simulation modeling, precision agriculture. Now we have another guy in the town, artificial intelligence. It existed 40 years ago. We used to call them expert systems. Now they call it artificial intelligence.
okay. Yeah.
Sorry about this.
No, that's super helpful. And I would argue those models haven't necessarily disappeared. Some of the roots or the original source of those models are still being used.
I mean,
The source of the DSAT crop model, for example, has been, it's not me and my postdoc who develop a crop, those models have been developed in the 80s or even before. So they've been around for a minute, but we continuously advance them, add features, test them, benchmark them. So I hope that the framework we're applying today is more robust and creates better insights than those,
more tools,
were used 4 years ago.
Everybody have
But You know what? I think the model is one aspect, but the data we feed into the model, we keep coming back to that point, is really determining the outcome.
Everybody knows, even my mother knows. Garbage, garbage.
Yeah.
Let's go.
Yeah.
All right, any other responses to Jonas's question?
Can I propose to maybe break for lunch, and you're very welcome to talk to us during lunch if you've got more questions for the modelers as well. We're going to start with the report back from the interactive sessions. Yeah, without further ado, maybe we can start with hearing how the first interactive session went. Nicole?
Yeah, that sounds great. I'll take this thing. Okay. So our group was discussing the ways that what kind of policies exist or are planned to deal with climate change in the agricultural sector in different countries. How might science support the development of strong policies, and also thinking about what are the main priorities when we're thinking about all these different things. So when it came to policies, kind of unsurprisingly, one of the top one that everyone was talking about was the EU CAP policy, the EU Common Agricultural Policy. And in particular, we were talking about multi-level governance and the importance of the policy as it provides a sort of top-down structure, but also provides space for this sort of like multi-level governance to occur. The second big priority we were discussing were emissions versus income. So how do we manage emissions and reduce emissions while ensuring farmers' income? And so we were discussing sort of government provided compensation for new policy that might support mitigation but reduce farmers' income. And we were also discussing potential insurance against losses and damages that occur with climate change. And lastly, one that came up particularly for the region was the importance of policies to manage drought, and particularly new irrigation policies to manage potential droughts. Then when it came to our second question of how does science actually, scientific research support these different priorities, we were discussing the importance of data. So we already heard this morning from our colleagues at AgMIP the importance of the data in the models, and that was reiterated again during these sessions. How can we find both social and technical data that can support this kind of analysis and decision making? One question I thought was particularly interesting was how do we manage this kind of these long-term projections and the importance of this long-term timescales when governments tend to have quite short-term thinking, maybe in a year or two, depending on the election cycles. So how to bring those two worlds together. One key priority for the group was also transparency. How can we make both data and the decision-making process more transparent and bring those elements together? And lastly, just the importance of always being context-specific in our thinking with the policies and with the research. So that's just a quick summary of what we discussed. But there was also lots of other really interesting interventions and ideas mentioned.
Thank you so much, Nicole. And I was looking for Jonas to report back from our interactive session. Maybe I can kick off because I was the hand behind the. Is Jonas here?
Just stepped out.
Okay, it's okay. We can start maybe, and then please, participants. Yes, would you like to maybe start? Yeah. I only need to ask you to please open this. Yeah, you can take the seat.
Thank you.
Maybe you can introduce yourself.
Yes, I will, very briefly. Well, let me introduce myself, as it was requested. My name is nicknamed Sakis Gertsis. I'm coming from Thessaloniki, from Perotis College of the American Farm School. It is the only private college in agriculture in Greece. We are a private college. We are not a state college. We might become, according to the very recent legislation, but I don't know. I'm an agronomist. You know, everything goes back to politics. I'm an agronomist. I'm soil science, crop physiology, simulation, modeling, and precision agriculture recently. I've been working with simulation models about 40 years ago when I was a student in the United States. That was the golden era of simulation modeling. That's where it all started. So I'm a teacher, I'm a researcher, and I'm a farmer. I have a tendency to talk and think like a farmer more rather than as a teacher. I will close this parenthesis and I will go back to start presenting our session. We have to answer, I think I speak loud enough so everybody can hear me.
Mm-hmm.
So, farm management decision. I'm not gonna put them in order of priority because there is a dynamic interlinkage among all of them. So let's start with the water. Irrigated agriculture is the productive agriculture. Non-irrigated agriculture is a high risk. So irrigation, the water, it's a management decision that is subject to climate risk. When we will irrigate, how much? Then another important input is pesticides. Pesticides is a collective term, includes agrochemicals such as insecticides, fungicides, herbicides, biocides, and other sites. These are all registered products. Very recently, we are using also some supplementary products which are called biostimulants. These products are registered, not actually, they are not registered. They are compatible, they can use them in organic agriculture. So you understand that these products are supplementary and they support plant health. Well, the first choice a farmer has to do is what kind of cultivar I'm going to grow. And that cultivar, based on his experience, but based on knowledge that some others supporting him, must meet with the new climate change. Corn is a prime example. There are varieties of corn maturing in 80 days, 100 days, 120 days, 150, 200, etc. So it's a critical choice. And planting time and harvesting time are very critical decisions, and they are dependent strongly on climate. So it's a high risk. Am I going to plant this week because it's a forecast for weather in 10 days so I can catch up the soil moisture, or it may be too much rain that I'm going to lose my seeds and I need to replant it, high cost. The cost of seeds nowadays is very important. Now we're talking about field crops. Managing trees, perennial species, it's a different chapter, different type of decision. Which system, field crops, vegetables, or trees, is more risk, climate change dependent? In my opinion, the vegetables. Field crops, you can manage them more or less easier. Perennial species is you go to a church and pray to God. Yeah, it's giving a great help today. Yes, this next question is, what information is needed to become available to farmers to facilitate decision on the first part? So the farmers need information, not data. The farmers don't care about data, information. So they have to be assisted by providing them with early warning system, state organizations or private organizations, mainly state. Short-term and long-term forecasting, very critical. And it's got to be reliable.
Yeah, these words, trusted, reliable, and consistent, especially in the system. Like once this information are systematized and provided regularly, that's when you create.
Well, by default, I don't mention that it should be reliable. It should be consistent by default. If it's not, better talk about something else. Information provided should be reliable by default. Otherwise, garbage in, garbage out. And
that's
then
a lot of the day.
We're going to a financial supporting system. The farmer needs support, not only on information, not only on software, not only training, but he needs someone to provide money. Money is the fuel for the farmer. It's not good wording and good models, etc. He can make money, but he needs also to be given money, to be supported. Now, a banking system, European Union has the strongest financial supporting system of agriculture in the world. European farmers are lucky as compared to American farmers or other countries' farmers, and they don't take advantage of this. Why? Either they don't know, because they were never told, or they don't use it appropriately. So, a very few years, there is a very important function in European Union, by European Union, I'm talking about Greece, that has not been fully implemented, is the agricultural consulting. United States, on the other hand, it's very lucky because they have the best agricultural extension system in the world. Some of you don't realize how important it is for the farmer. So European Union was behind on that system. They are trying to develop something close to that, but in Greece is not yet implemented. So all of
And
this.
maybe we can say that exactly what seemed to be the nexus between, all the climate data that farmers need to access and how they access that data, and discussing whether there is need for capacity building, there is need to share success stories to make the sector more attractive to young generations. There's need for moderators, facilitators to make this kind of information understandable. But really, the center between the science and the capacity building goes down to policy. So it was also said that if this is part of isolated efforts and not a systemic approach that is integrated into the national strategy of a country, it is very difficult to make it, well, as we said, continuous and reliable, and change the culture as well, all the social factors that I think Federica was mentioning this morning. So I think that we did, in a way, already identified the bridge between all of this and that other session.
Yeah. It's a very dynamic system. That's why you cannot put them in terms of importance. Every component is important, not necessarily equally, but it's like a chain. If you break one part of the chain, the whole chain will be broken. So I hope I was brief enough.
Yeah, thank you. This is also our first, maybe, it was a first occasion, I guess, to start reflecting on some of the things that were proposed during the day, and that they also could, hear during the morning, and then discussing together from also a research perspective how they can be relevant, I guess, for us.
Absolutely, yeah.
So that kind of,
Yeah, definitely. So Terry has talked to all the farmers in Greece. They say that water is an issue. They're looking 20 years in the future. They're wondering if they can keep their trees alive. Harvest season is changing. There's a change in quality and amount. Some of them want to keep with tradition. Some of them want to do something, but they don't exactly know how or where is the water we want to irrigate with. Dimitri has talked to olive growers, but also pistachio nut farmers and apricots. They're both aware of the problem. Again, water is an issue. Some of them are trying to plant avocados in the same place, and hopefully that will solve the problem. There's the issue of olives. A lot of times are planted on slopes, and irrigation is hard to get going there. Then Dimitri is saying that farmers in Greece, 95% only have an elementary level education. In addition, 65% are older than 65 years old. So we have to find a way to convey this information, but also educate them on how to use this information, which was previously discussed. And then Sasha was talking about she has been working on projects in Albania and North Macedonia, where there's similar problems, especially with funding at a national level. She was saying that energy-wise, there's a lot of funding, but for agriculture, there's not as much. So it's crucial to focus on policymakers to try to push them to get funding for agricultural solutions. And I guess, and then Dimitri raised 2 points. One is if you give 6-month forecast to a farmer, how many of them will be able to understand what's going on and how many of them are willing to do something about it or able to? And then furthermore, if we can get in touch with universities or other research institutions for them to have a course or some sort of educational tool to start providing information to farmers. Hopefully that will trickle down within the farming community.
I know it's been a long day, so I thank you all just for this last bit of your energy. After this, we're going to hear just from a few more final speakers, and we'll have some time to kind of bring everything together in their panel as well. We'll share this around, so you're welcome to take a picture now, but if you want a high definition version, there will be three, one summarizing the morning panel, and then there's this one, and then what's the last one, Krista?
Basically, it's this one, the first one, and the middle. So the technical part of the first part.
Oh, yes,
of the panel, the technical part.
Yeah. So there will be these kind of summaries also for the first panel and for the technical session. So I just wanted to take a moment now to kind of get feedback from everyone on this, because this is something that will help us be framing how we tackle the next phases of our research, and we want to make sure it actually reflects everyone's opinions. So also kind of like as we talk through this, we can see if there's any additional linkages that we want to highlight. This is a living document, so it can be moved and it can be changed. So as we've heard kind of for like the knowledge and for the effective policy responses, we've talked a lot about kind of like subsidizing and insurance. And we've also can see maybe how that might be linked to kind of this whole question of irrigation and water management and farms that are susceptible to climate impact. So perhaps that's the linkage there, for example. So I'm just going to kind of, after giving that example, I'm not sure if anyone else here sees any connections between these two conversations that we've just had, or even with conversations that we've been having earlier in the day. So this is kind of an opportunity for people to share their summarizing thoughts and words. Does that make sense? Okay, I can tease out a few more maybe if that would be helpful. So for example, this morning, we heard some really interesting things from our speakers on the first panel that I think are also very relevant here when it comes to future-proofing the farm and for knowledge and effective policy responses. So we talked about how do we actually scale farming solutions. So I think that's definitely an important interlinkage here between the two that was brought up by our colleague joining from DG Agri. Also, another thing that was important was how do we assess how these national budgets are used, which I think is also very relevant here when we think about how do we support farmers in being more profitable, but also how do we finance these various insurance and loss and damage and subsidy schemes, but then how do we kind of manage the monitoring and evaluation afterwards at the research level. Something else I think that was really interesting from this morning from the panels was how do decision makers coordinate? And I think that was also coming up a lot today in the knowledge and effective policy responses when we were talking about different levels of governance and how that might be filtering down to the subnational level. So I think that's another thing that can be kind of explored between the two. And maybe the last thing I'll mention here is what I thought was a really interesting comment from our colleagues this morning on the panel. When it comes, and also this came up, I think, in the intervention from future-proofing the farm, is when it comes to actually engaging with farmers, farmers aren't really interested in data, right? They're interested in information. They're interested in the bigger story, how this links to the histories and the culture and the traditions of farming. So I think that's another important linkage that we've seen between future-proofing the farms and the kind of knowledge we're preparing and how we're presenting it, that what comes up when we do this knowledge for policy response. So those are just some other examples, but I want to see if there's anything else anyone wanted to kind of add to these graphics that we'll be using and circulating. Any other ideas that are coming up for people? Really, yeah.
I forgot to mention something. We were talking about the very great value of the creation and establishment of living laboratories or demonstration of success stories. So the farmers can go and see, not only the farmers, any stakeholder think of a place that we demonstrate what we are advising for the farmers to do. So not only the farmers can benefit from coming and even get trained on those places, but we can talk to some policy makers. You guys come over here, see it with your own eyes. Don't need to read because you don't read. So see it with your own eyes what is actual agriculture and how we can make it better. So these living labs, you call them living labs, you call them demonstration sites, whatever, they will be of extreme value. Or then we can demonstrate a model there. That would be long-term establishment in various places, not necessarily in institutions, can be even selected farmers. I think this will add value to everything we talked about. We can apply whatever we say, whatever we have created, models, practices, whatever. That's mention that.
That's a great point, and I think it's kind of moving the other way across the diagram, which I wasn't very good at thinking about. How can we take this future-proofing the farm and use it to demonstrate the type of knowledge that is useful for effective policy response? And I think that's very powerful. One question I have for you and also for other people here is, I'm imagining this group of policymakers coming to this pilot, to this farm, very exciting. How do we find those people? How do we find the right people to kind of to bring to that farm, the kind of people who can actually make a difference? I think that's been a big question for us. How do we find the people who could really benefit from that kind of engagement and who have the power to make a difference? And that's a question I'll also maybe pose to the group.
And so the other point that I would raise on the connections here are sort of integrating across scales. So both in terms of long-term information informing short-term decisions and policy. The long-term information in informing short-term decisions in the sense of making sure that short-term decisions don't lead to bad adaptation choices, but that take into account what needs to be done in the longer term. But at the same time, short-term adaptation decisions are important because otherwise there are going to be losses and opportunities missed in the short term before something can be done on the long term. So it's those two levels of decision-making interacting. And also policy needing to support farmer decisions, so decisions at the farm level. And at the same time, so support policy needs to be informed by the decisions that farmers need to make in order to be more resilient. And at the same time, those decisions can help to shape what policy needs to accomplish. Because if more farmers are taking decisions to become more resilient and adapted, that changes what national policy actually needs to accomplish to improve resilience. So and the other point, the other overall point, and this one's obvious, but it just came across so strongly in today's discussions that I feel like we should capture it somewhere, is just the essential nature of co-creating the research products in a way that we still, I mean, AgMIP is very much trying to do this, but even within AgMIP, I think we need to push harder to make sure that what the research is producing are outputs that can actually be translated into decisions at the end of the day. That is definitely what we're aiming for, but we're not quite there yet, and that's a really important thing today.
Now, just to complement to the three things that you said, Malgosia, for those three things, we need context-specific data, context-specific information. I think that is critical for this, and that's what we will also discuss in our group.
Okay. Are there any other thoughts, reactions to these points or other things that have come through for you strongly today that you're really taking away from the conversations we've been having?
Was anything surprising at all in the conversations today? We're discussing, I think, in our interactive group that something that I, and maybe some other project team members found surprising is this idea that information that we expected farmers to be the most knowledgeable people on may actually not be as, farmers may still need some interpretation and some support in interpreting some of the data that arrive to them. So basically information about soil quality, I think it was mentioned, that was assumed that, the farmer would know that because it's his own farm, but then maybe that's not the case. And so we need to work. I think it was interesting to elaborate more on this notion of it's not necessarily always realistic to think that data as it is can be interpreted by farmers. It's not realistic to think about a capacity building training that equips everybody with the skills to obviously understand the kind of presentation that maybe we're here today. But we need to really work on that middle step, that middle man, middle women, middle people that can really, facilitate this discussion. And this can look like many different support systems. It can look like real people, as we were saying, leaders, people that have got a voice in a community and that can be influencers in a way. And it can look like technological innovation, of course, sometimes for younger generations, but not only. And it can look like communication techniques like the success stories that can also make a sector in a way declining from the point of view of the attractiveness to young people shine again in light of the way in which success stories are communicated. So I think this is also something that is not, the first part was surprising, the second part was more something I hadn't necessarily thought about, and I thought it's an interesting way to also consider the need for an all society approach in this kind of like facilitation role.
I think a point that's related to that, just to follow up, is that the research process really should include an understanding and a plan for how the information is going to get to the decision makers, whether farmers or other decision makers, because not only do they need to understand the information and it needs to be relevant to the decisions that they're making, they also need to trust it. And that needs to be part of the research process, so we may never get to that. And one more thing, to follow up on Roberto's point about the importance of context-specific data, I think this notion of context-specific, written more broadly than just across, is really important in a lot of our discussions today. That approaches the type of information that's needed, approaches to providing an adaptation solutions more broadly, means we know that there's no one thing that's going to work across the board. There needs to be everything that we're developing needs to be context.
So maybe it was mentioned before, but I want to say that all of this is very context specific and depends on local realities. And that's a little bit of a higher comment. And it's, one of the surprising realizations I had during our breakout group is how different the agricultural sector here is, obviously to the US, but also to other countries, in France and in Germany. In the US, pretty much every farmer works with an extension agent. They're savvy, they use weather data, they know how to interact with breeding companies, and they're on top of their game. And that may not be the case everywhere else. So as we heard in Greece, there isn't the extension agent is not a thing here, and there's very little work on that front. So a roadmap, a strategy to develop something like that needs to be very context specific in that regard. And maybe one important thing that works here is very central to this approach here is creating a platform, a channel where we contribute to make data we produce accessible and trusted and quality controlled. Some
low-hanging entry point for a farmer to actually look up some of the, and not develop the science too much, but really provide the, the data that's already there in a transparent and clear form. And then think about the fancy science.
Okay, are any final points?
Here, also we had a discussion in our team, in our online team, that it's also of high importance to identify and negotiate the form, how we translate the modeling and model results and all the evidence to the policymakers. So how we really push forward all of those models, how to use them, how to implement, to receive actually some results, and to receive changes in the development of the agriculture processes and agriculture sector development. So the main point that we were discussing, this is the result, the outcome of all these research studies and modeling. So I would say that for me, that was the most important. And that's why I think that Augures project is one of the crucial projects, and that could bring really an added value for the decision makers and could open the floor for researchers to speak with the data, to speak with the model results, and they just should be heard, and some decisions should be implemented afterwards. So let's concentrate on that, and we will move forward with the activities of Augures.
I was just wondering whether Dimitri had anything to add to these final reflections before we start the final panel for the day.
I think between Sasha, Eric, and Nicole, I think almost all the important points that were made in our group have been mentioned. I don't really have anything else that's important to add, except to re-emphasize what you've been talking. Apologies for my voice. What we have been talking at the last moment, that has to do with the capacity of farmers to be able to use the information and, first of all, to understand it, possibly then act on it. So that is really important, and I think that was already mentioned a couple of times, but I thought that it was important to underline it also from my point of view. The second aspect I think that I would like to also add, it has to do with using media both to inform farmers, but also to get some pressure on policymakers from the ground up to do something about providing a little bit more resources, helping a little bit more in more concrete terms the farming community to adjust and transform their practices possibly so that they'll become a little bit more climate proof.
In the first part, that part about dialogues, interconnections, multi-stakeholder interactions, we'll have two speakers. And the first one is, and we've been talking about the common agricultural policy, which we all kind of know, but maybe not everybody in the room, especially our colleagues from across the pond, know maybe super well, or even the Europeans. And that's why it's great to have here the so-called EU CAP network, which is basically, we'll hear more about who that is. We have Xurxo Veira, who represents this network, and he is a research and innovation officer in the EIP Agri Support Facility. It's another acronym. You know, the European Union is very full of various acronyms, so we'll ask you to decipher it for us here. You are working currently as associate researcher in the land laboratory, collaborating projects on several topics such as, and you won't be surprised that they are super relevant to our conversation, food security, food systems, sustainable land planning, resilience, biogovernance, ecosystem services, and rural development. So if I can ask you to come over here and tell us about how the EU CAP, well, first of all, what is the EU Common Agricultural Policy, how those aspects here are or are not reflected in the current CAP, in the future versions of that, and how your network, how you find this useful to your network, and how can the network engage with this project and co-shape this. So how should we do it? We have slides, right? Yes. So why don't you sit here? Okay. Closer to the mic.
Or so we spend work, we're gonna share a line.
So thank you very much. Thank you for inviting me to participate in this workshop. So yeah, I will briefly present our activity and especially focus on the innovation and knowledge exchange EAP Agri. So next slide. So the innovation and knowledge exchange is only a branch of the UCAP network. UCAP network is a group of people. Well, in fact, there are 4 groups of people working and supporting the activities that are developed under the Common Agricultural Policy. So the Common Agricultural Policy, for those you don't know, is well the commitment of the member states, of the European member state, with the farmers and agriculture in Europe, and also with food security. And it addresses not only, let's say, issues that affect directly the farmer, like a fair income, for example, but also rural development and environmental protection, and also landscape. So it addresses a variety of topics in relation with agriculture. And it's well, it's financed by the European Commission through a very complex system that I'm not going to enter because I'm not an expert in that. So, but it's for the next period is based on. So basically, each member state makes like a kind of plan and decide on a kind of a list of topics or conditions that the farmers from this country should accomplish to receive the funding from the European Union. And this plan is agreed, of course, with the European Union, with the European Commission at the European level. So the UCAP network is supporting the activities from the Common Agricultural Policy, and it's divided in 4 groups, as you can see there. So we have the implementation group, we have the evaluation group, which are in charge of the implementation of the measures or the evaluation of these conditions that farmers must accomplish. And there are also a transversal group, which is the communication and event support team, but there is also the innovation and knowledge exchange EAP Agri, which is where I work, and I'm going to explain. And our team is the support facility, the EAP support facility. We are a group of more than 15 institutions. We are distributed along Europe. Of course, we have people in Brussels, but we work from our respective countries. For example, in my case, I'm Spanish, and I work from Spain, from the University of Santiago de Compostela, which is a member of the support facility. So what is our main objective is to speed up innovation in agriculture in Europe, and also to put in contact all the stakeholders to exchange knowledge, exchange idea, and create. So basically, we try to bridge the gap between the practice in agriculture and the research side. as you can see in the slide, practice is more covered by the common agricultural policy, the operational groups linked to that policy, and the research is the purely research side is mostly covered at European level by the Horizon program. So we try to make to put in contact these two worlds and to make a bridge between. How can we do that? For example, by identifying research needs from practice side and communicate these needs to the Horizon, to the researchers, or by providing opportunities for researchers to test new ideas in the field, in the farms. Next. So this is basically what we do: identify research needs, knowledge exchange, and provide opportunities for co-creation and for applying solutions in the field. New solutions, or spread already existing solutions. And one key point in our activity is the interaction. So we try to maximize interaction between agricultural stakeholders. Next. So basically, these are our main activities. We organize different kind of events, from, for example, focus groups, which are events. Are groups or around 20 experts that meets twice on a year, and they discuss over a very specific topic. Then we have workshops and seminars and also conferences, which are bigger groups. The workshop usually between 80 and 100 people, and seminars are 120 persons, and the conference are more than 200 persons, and they discuss on a more widely topic. And then we have also another kind of events, which are brokerage events, which are events specifically focused on networking, but we also organize brokerage activities within the other events. So a workshop can have half a day of brokerage activities linked to it. We also organize field visits linked to the workshop, but also we organize cross visits between operational groups between two countries to visit each other and see practical examples in the field. So normally these operational groups are focused or study a very similar topic. And our task is to invite to those events, put all the stakeholders, farmers, researchers, advisory system, but also NGOs, farmers associations, all together and discuss on a topic. All the events has had and have in the end a final report, and all the information we gather from these events, including this final report, is published online. We have a web page where we also have a news sections where you can know more about our activity, or past activity and future activities. But you also have a lot of information there from all the events. And we also have a lot of different kinds of publications, newsletters, magazines, press articles, social media in Twitter and Facebook. And we disseminate all the results of the events, but also interesting studies, case studies, or interesting ideas that we find in the field. Next slide. So the website, well, you have the QR code for the social media there. The website is, if you Google UCAP network, you can find it. I invite you to enter and read all the sections. I think the most important for you could be the news and events section, where you can find information on past and future events. We will publish when we organize a new event, and participants have a period to apply to be part of the workshop, of the seminar. So we will publish in social media and also on the web page the news, so that everybody who is interested in can apply. We also have a networking session where you can also find these needs from practice, research needs from practice. We publish every year a report where we collect all this information. And you also have the projects and practice section, where the most important part is next slide, is the UCAP network, the EEP Agri project database. It's a database where we collect all the projects we find on the online. It's currently we have more than 3,000 operational groups and 500 research and innovation projects, including the Horizon multi-actor projects. So it's really a very big, we don't have everything, but we have really a lot of projects, past and present projects. For example, on the topic of climate change, you can find more than 500 projects, and 381 of them are operational group. For Greece, you have 14 projects. There is more. There is almost currently around 40, but reflected on the web page, on the database, you only can find 14 projects. But there are around 40 projects, operational groups in Greece related with climate change, and around 200 projects, 200 operational groups currently. Yes, next slide. So this is our calendar for this the next year. We start every working year in October and finalize around June, July. And these are the events we plan for this year, this working period. And I think that the most interesting for you, because it's very related with the topic of the workshop, which is climate change, are the two first focus groups. Focus groups meets now in November and in April. They are already set up. There are 20 experts per focus group, but final report will be published in June, July next year. So maybe the final report for the production of protein crops under climate change and the local perennial plant genetic resources in relation with climate change and biodiversity loss, maybe these two are very interested for you. We also have a specific workshop on networking, which is planned for January, but I am not sure this time if it will be in January or later. We also have a standalone brokerage event, which is planned for spring. We don't know the dates yet, because this will be linked to the Horizon calls. So we are waiting for the Horizon program to publish the calls, and then we will organize a linked brokerage activity, so that people can join and discuss on the call, on the Horizon call. And well, we also have multiple visits, which are visits from two different operational groups working on a similar topic, and they can visit each other and see in the field what is happening or what they have been doing. Next slide. So
Can we maybe wrap up?
yeah, of course. Yeah, just to finalize, just a reflection. How can we contribute to a more resilient agriculture and to food security in Europe? This is basically putting all the stakeholders, as we have been doing, together and providing opportunity to interact and to discuss, and also facilitate the networking among all the stakeholders, and of course disseminate all the knowledge and that we gather and among all the stakeholders and through our net, and including the research needs from practice, which are reflected in the report that you can find in the webpage. So thank you very much. That's all from my side. I invite you to visit the webpage, also to follow us on social media, and also to follow us our publications and subscribe to the publications. So thank you very much.
Thank you very much, Xurxo. And I think it is obvious from your presentation how people here can benefit from engagement in the network, and ourselves including, and I think especially at this stage of Augures project. But can you share with us sort of, I'm encouraging you to sort of go off script a little bit in sort of like, was there anything for your daily work from this meeting and from sort of our big plans, right, for development of Augures that would benefit your sort of, you know, networking, or maybe the sort of the topics that you cover? Or I don't know, some recommendations that I guess you also would be providing
yes,
to the shapers of EU policy, right?
Yeah, yeah, I think because listening to the reflections, I think we have a very similar points, and in all, or in it's some of the reflections that have been told here also frequently appear in our workshops. But I think if I have to choose one, I will remark especially what has been said here in relation with the communication to farmers, because this is for us, farmers are a central point of our activity. So we try always to involve farmers, as much farmers as possible in our events, and it's not always easy because of language, but language not in the sense of different languages that you all know that we live in Europe. Every country has different languages, so it's a challenge because normally as farmers do not speak English, or do not speak English very well. So it's complicated to them to access to this kind of information, to come to our events and discuss with other people. So it's very complicated. We try to encourage them. We always, or sometimes, we provided them the opportunity to come with another person that can act as a translator for them. But it's not always easy. Also because they also have their own times. Sometimes they have works in the farm, so our event is not it's at the same time that, and they need to be at the farm because they are in the harvest period or something like that, so they cannot come. We also try to adapt a little bit the time of our events to the availability of farmers, but also because farmers speak different languages than the environmentalists, a different language than the researchers, and they have their own language. So it's very complicated really to put all of them together and discuss. And
a bit like modelers, right, who speak their own language.
Yeah.
That's why it's fascinating to bring that together. Thank you so much for this. And I think, do we have Angela, right, already? Yeah, perfect. So then we are moving to Angela Cordeiro, who is a co-director of Agroecology Fund, who is a multi-donor fund with a mission of transforming food systems. So I think Angela can tell us more about the fund, but just to note from her short bio that she has over 2 decades of experience as consultant provided services to Brazilian government, research institutes and UN agencies such as UNDP, FAO, and the World Food Programme. So very, very topical. And of course, you guys heard from my earlier introduction that currently this initiative is funded by philanthropy as well. Philanthropy is very often the first mover, but ultimately at some point next year, if we keep developing that service, philanthropy cannot fund a service like this for all countries in the world. I think there has to be some public money, there has to be maybe some private money, and so on. But for now, we wanted to just hear a perspective from Angela, from the fund that, whose funding is focused on the topic of today's conversation. Thank you very much for joining us. I think from Brazil, right? If I'm not mistaken. So thank you very much, and over to you. Let's see if the sound works.
Can you try speaking, Angela, please? Good morning, everyone from Brazil. Good afternoon in Greece, I suppose. We are some hours behind.
Yeah, it's 5 p.m. here, 5:15. Thank you.
Can you hear me?
Yes, very well.
Good. So thank you so much for the invitation. It's a pleasure to join this important meeting. Unfortunately, due to time zones, I could not follow the full session, but I have been hearing the speakers that are speaking this afternoon, and very interesting to many convergences and synergies with some topics that I will bring to share to you. So the Agroecology Fund is a pool of funders that was created in 2012. Mainly philanthropic foundations from the US. The Agroecology Fund started with 4 funders in 2012 to join efforts and funds to support grassroots collaboratives that were working to advance transformation of food systems based on the agroecology approach. Currently, Agroecology Fund has 55 funders, and one important element of the Agroecology Fund grant making is to support collaboratives that include multi-stakeholders, because we understand that transformation of food system is not only a task for farmers, but involves research, involves policymakers, involves consumers, involves different sectors of society. So what I will share with you today is some initiatives on collaboratives that Agroecology Fund has been supporting, that involve collaboratives between grassroots organizations and research groups to develop participatory action research to work on some open questions needed in order to scale successful initiatives already validated but in a more localized territory. So I will share my screen with you. If you go to the Agroecology Fund website, you can find the Agroecology Fund strategic plan. And there you will see the theory of change and principles that reinforce what I have said to you. But some important elements about the Agroecology Fund approach is to support collaborative action involving multiple stakeholders, embracing the diverse forms of the way that agroecology practice, learning, communication, advocacy express in the territories, and having the rights-based approach as a very important element of the agroecology initiatives that the Agroecology Fund supports. We also try to work in a grant-making system based on trust-based principles, and so trying to make the process more easy accessible to grassroots organizations, and to move to a practice that leads to a non-colonial collaboration. And so we try to establish a respectful relationship with partners and listen as much as we can, getting their feedback and try to improve our process and also the Agroecology Fund strategy. Well, that said, Agroecology Fund supports collaboratives that includes partnership with researchers and research institutes and researchers as individuals, depending on the context. And this is done through the main grant program of the Agroecology Fund. And one that I can mention to you as an example is this work developed in Central Asia by partners from different countries, Mongolia, Kyrgyzstan, to revive Buryat cows and also Xurxo in Central Asia. And this involved a very important collaboration with researchers from different universities and institutes in order to make this work possible. This demand came from local communities and local organizations. And so this collaborative built this partnership in order to advance with this program. The first one with the Buryat cows, that breed was almost disappearing. They managed to come to many interesting research results and getting that this breed is already recognized again by the public programs that they have in the country. And they managed to have a population that were big enough to multiply and get back to the farmers. And they are in the same process working with the Kyrgyz horse in Kyrgyzstan. These breeds, they are very important. They are more adapted to the conditions that they have in the region. And this is a key component of the community's strategy in order to cope with climate change. But this is just one example of the different grants that Agroecology Fund has awarded from 2012 to 2023 in our core grant program. And so far, it's around $20 million US that Agroecology Fund has provided to support collaboratives in more than 19 countries. And since 2021, Agroecology Fund is also launching regional funds in order to decentralize the grant-making process. So the first one was in 2021 to support initiatives in the Yucatan Peninsula. We started in 2022 the regional fund in India, and this year we are launching the regional funds in West Africa and East Africa. And basically we replicate the same approach that we have through the global grant program to support collaboratives and support initiatives that are trying to develop in participatory research projects to answer key questions that they have to scale or to better develop their initiatives. One important initiative, this one was a grant call that we launched specifically to support participatory research last year with financial support of the IGRC from Canada and also other funds from the Agroecology Fund. And this initiative has 7 collaboratives participating from Mexico, from Guatemala, from Cuba, from Nicaragua, from Colombia, from Ecuador, from Peru. And they are working in different topics because the idea is that we do not impose, you should do research on that, on that, on that. The call was like, what are the key questions, the key research questions that you have to advance the work that you have been doing and that you have already validated in some territories. And in Latin America, we use a lot the concept of territorialization of agroecology, that it's scaling up agroecology. And think in terms of the territory, not only as the geographic space, but a space that has relationships, that has culture, that has the natural resource and different systems of governance of this natural resource. And of course, the political system that these initiatives are embedded. And basically, we have initiatives from the Andean, Central American, and the Caribbean, and plus Mexico. It started implementation April last year. We went in June next year. And we have the scientific support from the Agroecology Research Group from Ecosur, a public university from Mexico. And they have a research group on agroecology that it was created in 2014, 10 years. And they have also a master program on agroecology that they receive students for all Latin American, including from other regions. And they are the ones that are providing the methodological and scientific support to this cohort of grants, and also facilitating the learning community. So this group also meet online and meet in person. We had the first meeting last year in Ecuador, a second meeting this year in Cuba, and the last meeting will be next year in May in Peru, in the Potato Park. And in these meetings, it's an opportunity for people to exchange learnings, to learn about each other, about the methodology and main findings, finding synergies and convergences. And among this group, we have a group of topics that many of them are working on the same issues. And so there is a lot of learning exchange among the group. The other initiative that we are just starting this year is another sister of what we call the IPALAC, that is one that we started last year, that the IPA Global Initiative. More or less, it has the same structure. We have open grant call asking partners what are the open questions that they have in order to strengthen climate resilience and to strengthen their advocacy work to create a better environment for developing, advancing the initiatives that they have already developed. I heard from some of you that were speaking when I just entered the session about the importance of influencing policymakers, because we can develop very nice, beautiful initiatives. They are very localized, but they do not scale because we have many constraints in terms of policy, regulation, funding, access to credit, the way that markets are organized. And so these initiatives, the focus is on working on research questions that are relevant for these territories in terms of reinforcing their advocacy strategy. It also involves collaboration with research groups, academic institutions in the different countries that are joining these social movements, civil society platforms to work on these questions and also use the learnings from this research process to reinforce their advocacy strategy and also to influence policymakers to bring more evidence and communicate that in a language that they can understand, they can learn, and hopefully be motivated to change the way that policy and programs in agriculture, but not only in agriculture, are designed, and in many cases are the main drivers of bad things that are happening in terms of the impacts of the food systems on climate. For this call, we have funds from the Waverly Street Foundation, is one of the donors to the Agroecology Fund. And we have, it's not a global call, we are working some target countries that include some of the G20 countries and some non-G20 countries. We can see the map. The ones in green are grants that are already were just approved. The ones in gray are still in finalizing the review process. And basically they are starting now. Is first we have a first phase of 2 years, and then probably we have a renewal for more 2 years. And what we expect during this process, first having a very active learning community among this cohort and getting lessons from the different research questions that they are working in each country, and also the advocacy strategy, and have a set of evidence that could be good policy advocacy tools for the civil society in their countries to advance better regulatory and policy and program frameworks towards resilient food systems. Another initiative that we have, we work in the other piece. Basically, the Grassroots Evidence for Agroecology was an initiative that we started in 2021 and 22. We ran a pilot in partnership with Statistics for Sustainable Development. That is an organization based in UK and is composed by statisticians and many other researchers that have worked in the past in different academic institutions, such as the Reading University. And we heard a lot from funders. We need more evidence. We need more evidence. And there are many efforts in this area. We know about the TAPE initiative that has been developing and promoting by FAO, but we have asked ourselves what we could provide to partners that are in the field, that are facing the problems, that are finding the solutions, that are working to find response to the challenge that they face in order to give visibility and communicate this evidence generated on the ground to the audience that they can, that are relevant and important for them. And so we have come to, from the pilot, we have come to an online course in a very simple methodology. And basically the approach that we have to evidence is that sometimes evidence is confused with data or information. We understand that evidence is when we have a good argument that is communicated in a language that this audience that we are trying to increase the awareness or to influence, they can understand. And so basically the idea is that they should define their audience, their case, also the audience, and think what are the doubts that this audience has in mind regarding something that we are very sure about, we have tried, we have tested, and we know that this works and this can be scaled. That could be a practice, that could be a strategy, that could be a methodology. And then what are the information and data that are necessary to make this case robust and a real evidence that can influence the attitude and behavior of others, and organize this information and data and prepare a communication output that communicates to this audience. So includes a lot the reflection about the issues on communication that the previous speaker was talking about. Here you can see the link. I will share also in the chat about the online course that is open, is available in French, English, and Spanish. And our partners from Central Asia asked us to prepare a version in Russian that will be available in the coming months. And here also we provide some financial support to Agroecology Fund grantees that they can also have some extra financial support to dedicate work to work on this evidence case building, involving also partnership with researchers, research groups, postgraduate students that can help them to work on the preparation of the data and information needed to communicate to this audience. That could be farmers, could be policymakers, could be the researchers, could be consumers. They define what they want to do. And basically what I can share with you in terms of the key learnings on this participatory action research processes supported by the Agroecology Fund. I also added to this reflection my previous experience working with researchers in Brazil and in other countries about participatory research and the challenges and opportunities that this brings. I think one key issue is timing for producing research outputs versus the social process involved in participatory action research. There is a pressure on researchers that they should publish, that they should produce outputs, including to raise more funds to keeping their research programs working. And this many times creates some kind of barriers because when you start to work and develop participatory research involving communities, there are social processes that takes time. And so this has been also always an issue to deal with. And it's very important to have these kind of conversations and agreements since the very beginning in order to find a schedule, a timeline that is feasible for both sides. And both sides have a deal, an agreement to move together in that direction. Balance between research and action. When we work with participatory action research, especially grassroots organizations, they are very good and put lots of energy in the action component. And so this is also something that we have learned that is very important to have very good conversations about that, to understand the need for a balance between the two areas. And this has been, for example, one of the topics that we have in the learning community of this Latin American initiative I have mentioned to you.
And Angela, sorry, can you hear me?
Yes, I should finish, right?
Yeah, thank you. Sorry, because
okay, so the multidisciplinary and systemic approach, I think it's an issue versus the research design. So when you work with diverse farming systems or diverse food systems, it's complicated if you want only to focus on this crop and that crop, because from the producer's perspective, it's a systemic thing. And so this puts some challenges in terms of research design. I think skills in terms of participatory in co-creation process from researcher sides versus the grassroots organizations' viability to engage in more academic research initiatives. The communication strategy, it's a key issue, and also the limited institutional support that researchers face to adopt participatory action research approach. Lack of funds, some performance assessment systems that put big pressure on publication, and you need to go through the process of building trust relationships, research agenda priorities, among others. I will stop here. Sorry if it took too long. I'm sharing in the link one short article about these two initiatives, and you can go to the Agroecology Fund website and find more information. Thank you.
Thank you so much. One thing that I took away, and yeah, thank you again for maybe reminding us of some of this. One was this grassroots engaging collaboratives and so on, which we heard also in the European context. I think that was really important. But also, you're talking mostly about developing countries, right? And that also reminds me of something that, you know, lots of the stuff we are discussing is affected by who is the most powerful country, right? And even within the EU, we know that, right? That some Western European member states have more influence and they can take care of their issues better than the sort of Eastern Europe or Southeastern Europe and so on, so on. So I think eventually we want this service to be of help not only to the sort of big agricultural powerhouses of Europe, but to any country, including the countries that you guys are working on. So I think it's, you know, I think it's a good reminder that, you know, there is a world outside Europe, and yeah, to solve the climate problem, we need to be active everywhere. But obviously our project is going step by step because we need to develop the solid approach in the smaller geographies and then go further. So thank you so much. We are running a bit out of time, but just wanted to see if there are any immediate reactions to either of the presentation by Xurxo or by Angela. If not, if there's nothing online, then I think we'll move on. So now we have one more presentation, and as already announced, we have online Ignacio Perez Dominguez, who is a senior scientist and team leader at Joint Research Center of the European Commission. He has 20 years experience, again, that is not surprising, in quantitative analysis, mainly with environmental, agricultural, and trade economics focus. Interesting to mention that before joining the European Commission, he worked for the Agricultural Economics Institute. Again, agriculture seems to be always prominent in your career, and the OECD. So, Ignacio, if you could tell us in the next 10 minutes, and I appreciate that you haven't been with us for most of the day, but since JRC is a key advisory group to the Informing European Policy, I think the workshop on the EU couldn't have been, you know, checked without JRC intervention. So please, the floor is yours.
Well, first of all, thanks for the invitation, and secondly, sorry for not being present today, but it was a bit of a crazy time here with the work program at the JRC and so many meetings, so I could not make it earlier. So my idea is to not to spend too much of your time, just to try to give you a couple of snapshots of the type of work that we are doing here, and that might be of interest for the purpose of your workshop. So I basically collected a couple of ideas, of elements of previous projects that have been dealing with climate change and the way we model climate change impacts in agriculture. The first thing, if this goes down there, exactly, is just to make you aware of the work we finalized here. It was like about 2 years ago when we finished the ZETA-4 study, where we basically used an ensemble of climate and biophysical models to produce different climate projections for the EU. And then we basically computed the impacts of climate change in the 2021-2050 period under different climate change scenarios. In this case, we modeled the 4.5 RCP radiation concentration pathway and 8.5, which is what used to be the kind of bad climate change pathway. And also try to have a look at how this would affect productivity in Europe for the main crop varieties that we grow here for food. So if you look at a little bit at the results that this had, that this has or potentially will have in basically 25 years down the road for wheat, you can see on the right-hand panel, this would be a rain-fed wheat in Europe that yields are potentially going down, but not by a lot, and also that the uncertainty is quite high. This is shown by the bars.
Sorry, were you meaning to share the screen because we can't see it?
I'm not sharing. I thought I was sharing.
No, that's why when you mentioned the right panel, I was like, wouldn't that would be fun?
Is that now shared?
Yeah, now it started.
No, not shared. Okay, sorry. Yeah.
Second, it's just loading. Let's check. Okay, yes, that's good.
Yeah.
There is a grade. Okay, maybe it's fine. Okay, that's good.
All right. So that was my first slide, basically. Well, that was the presentation. That was my first slide where I was basically introducing you to the project. And these are the results. Where you have you have fully irrigated in the left panel for wheat and rain-fed wheat production on the right. So you can see that we have much better estimates for fully irrigated agriculture, and that the yield scenarios. Here we are talking about yields that could be going up to a certain extent for wheat in Europe due to climate change. This is the important differentiation between wheat and maize. If you look, and then in the case of rain-fed, which is the right one, you see that the uncertainty is much higher. This is these hatching lines, but you already see the negative effects of climate change on the southern parts of Europe, with yields potentially going down between -10% and -25%. This is the pure biophysical effect of climate change. Similarly for maize, but the results are much more pronounced. You see the same thing, fully irrigated left, rain-fed on the right-hand side, and here you can see that yields for maize could be drastically going down in 20-25 years down the road, just in a scenario where climate change continues building up. So this type of work that has been published in several places, including journals, is telling us that some of that is not homogeneous. The impacts of climate change are not homogeneous across the different crop varieties in Europe. So C3 or C4 crop varieties do face different impacts. In this case, we saw the potentially large impacts on maize, which will imply that maybe in some locations no maize will be grown anymore unless there is irrigation. And then this north-south dipole. This is quite interesting because climate change, I mean, in this case, interpreting climate change as a gradual increase in temperature. I'm not presenting to you work on weather extremes. This is a different animal. We have done some work on this, but I have not. I don't think I have the time to go into weather extremes. We have a very large north-south dipole, but this is the biophysical side of it. What we do here in the JRCs, we do economic analysis, and you have a European market. So what some of this biophysical response to climate change provokes, these lower yields, this is an increase in price, and of course an increase of the profitability of growing these crops, which means that farmers will apply more inputs, that will try to find other locations that will replace crops. So this 30-40% yield decrease pure biophysical impact is not what you actually observe in the end, because of what we call this economic adaptation. You have adaptation in terms of bringing irrigation in place or facilitating trade. There's different adaptation mechanisms and policies, but one of them that is very much inherent to the system is that the market, that we have a consolidated market that actually does communicate. So it's not, so the production in France is totally correlated with the production in Spain, and prices are built across the EU. Now, I also mentioned high uncertainties for certain varieties like wheat, and adaptation, just to say that it could play a key role. This is a little bit on the climate change impacts, pure temperature increase. Now, what is the way forward? What we are actually doing at the GRC, and I am coordinating part of this work, is that we're trying to integrate different tools. And I think you, if I saw correctly the agenda, you were talking about different tools and the integration of different models to be able to analyze climate change. Now, what is the difficulty here? The difficulty here is that agriculture is not isolated, and that we have, of course, a bundle of sectors that are involved in here. The first one of them is the energy system, because depending on to which energy production we go, what kind of energy demand we're going to have in Europe in the next 20, 30, 50 years, then this will have implications. With this, I'm referring to the Fit for 55, or part of the Green Deal strategy, which means that a lot of the production will go into renewables, and then this will pose some pressure on biofuel markets, for instance, and also on the use of land for second generation biofuels and other types of crops. So what we are doing is we are trying to establish connections between a land use model, between an agricultural economics model, a forestry model, an energy model, and a carbon accounting model for forestry. And this allows us to analyze not just non-CO2 emissions, like classical analysis of methane and nitrous oxide emissions from agriculture, but also carbon sequestration, and how the different use of land can contribute to sequester carbon. What they call, and I don't like very much this word, carbon farming, but part of this is involved in this analysis. These kind of tools allow for policy coherence, which means that agricultural and climate policies can go hand in hand, and then you can have a look at and energy policies, and then you can have a look at the trade-offs between I don't know, for example, energy security and biodiversity problems, or environmental sustainability, and so on. And the last point is a series of studies that we do, and this relates more to mitigation, to trying to avoid those emissions to take place. So it's not so much related to adaptation and impacts that I mentioned before. And it's a series of studies that I've been leading since more than 10 years now, with economic assessment of different strategies for reducing emissions from agriculture. And here we go straight to the technologies. We go to precision farming. We go to the use of winter cover crops. We go to preserving organic soils, so that the carbon content is there. You have here a series of techniques, feed additives, increase the legume share in pastures, the way of producing gas anaerobic digestion with in different countries, and we did a series of scenarios. One of them is afforestation, one is forest management, another one is protection of histosols, and then we kind of go into a more comprehensive policy which introduces carbon pricing to incentivize the uptake of these technologies. And without going too much into detail, just to tell you that this is that we're trying to, on the one side, to try to adapt to this climate change. We are also trying to have a look at weather extremes. On the other side, we're trying to mitigate, in the sense that we try to make the agricultural sector less carbon intensive, because all in all, Europe is going towards a direction where carbon neutrality will be probably met quite easily in a lot of sectors, but not so much in agriculture. And this is something we have to acknowledge and potentially put on paper. So I think this is a little bit of the snapshots that I wanted to show to you. And of course, I'm open to questions, and maybe then you can bring me back to what you were discussing, which I don't know exactly, and make this my intervention a little more useful for your project. Thanks.
Well, thank you, Ignacio. I think one practical follow-up would be that we should have some more maybe bilateral follow-ups. I wonder if somebody from the room, I don't know, AgMIP colleagues or NOAA colleagues have something to maybe comment. I know you guys, Ignacio, I think you worked with somebody from the current AgMIP team before, right? So you guys know each other, obviously, but yeah, anything you want to offer in response to Ignacio's presentation would be that now is the time to do it. Also online, I think we are monitoring, right, if somebody's raising hands, so. Would you mind coming again? Sorry, because it's.
Just wanted to shout out real quick that our simulations look very similar, just supporting the analysis.
So Jonas saying our simulations are showing similar results. Ignacio, crop models.
That's reassuring.
Anybody else?
I have to admit that we are kind of updating a lot of things because we were using CMIP 5 still for this range of work, and we haven't been doing a lot of climate change impact analysis in the last year and a half, but we have prepared the data sets for CMIP 6. So probably in the next year or so we could update this.
Perhaps, hi Ignacio, this is Roberto.
Hi Roberto.
Perhaps one more thing that I should mention is that Ignacio has been, and ERC has been working on lifting also farm level models to more European level models with Capri and other models, right, Ignacio?
Yes. Mm-hmm. Yes, I'm by training expert in the Capri and AgLink model teams, and Capri used to have a farm layer. Now we have another model, IFM-CAP, and I don't know if Dimitris told me he would maybe join in the last session, but he was kind of busy. So we have a farm model in Europe running on all FADN farms, so a single farm model, and this is pretty much also linked to Capri and other more global economic models, but we are able to analyze farm performance for at least a very large set of farm types. Yeah.
Maybe I don't know if anybody's got any follow-up. Otherwise, I have a question for Xurxo and Angela. Actually, I'd like to ask you both to, in light of the kind of work that you do to integrate to find ways to integrate research in a system that is understandable and communicated by grassroots organizations or farmers. So in this kind of space, is there any key takeaway? We discussed many points today, but in maybe one or two key takeaways that you'd like the audience to leave with from this perspective, from the perspective of the kind of collaborations that are needed in order to achieve all the topics that the goals that we're discussing. But if we had to wrap everything, to boil everything down to maybe one or 2 points, what would that be?
Yes, if I may, yes. So key points, I think, in communication with farmers, I think we should try to keep as simple as possible all the products we have, either final reports or communication products, newsletter articles, so that they are understandable. They are not written in scientific language. We try to write so that people that has no idea of the topic can understand. I think this is very important. And regarding the type of communication, we have a lot of different kind of communication, social media, newsletter, online newsletter, but also magazines, also the web page. I think it's important to keep different channels of communication because you never know which channel will be used by the farmer. But also, ideally, it will be nice to, and we also try to use multipliers so that they can further spread advisory system when they use it or any other.
Thank you, that was very clear. And Angela, what about you in 30 seconds?
I think it's important to understand the knowledge system, the way that the knowledge system of each sector operates, what are the key questions, and the best way to communicate, as the colleague mentioned, what are the best formats for communicating the language, but also the entry point to start this dialogue. Communication is a multiple flow, and also to listen. I think it's important to listen in order to understand the best way to communicate.
Thank you so much.
All right, so thank you very much, all of you. Just to say that we made, I think, our initiative known to the world, and we started building the community. That was a big purpose of this meeting. So I want to, first of all, thank all of you here in the room and also online. So that's the biggest thanks is to you. Then the second cohort of thanks is to our consortium, our lovely consortium. Thank you very much, especially colleagues who traveled all the way from the US. So thank you very much. And then big thanks to my colleagues, Gaia and Nicola, for putting this workshop together. Thank you very much for that. So you will hear from us. It's not like the workshop is over, box ticked, and the report submitted somewhere, nobody will cares. To the contrary, here, this is just the beginning. You'll hear from us. We would propose various bilateral interactions. We want to truly reflect your views in our program. So it's not just, again, fulfilling some KPIs and forgetting. We really want to co-create that. That's why this PAR from Angela was so powerful, because we really want this to be co-created with stakeholders. And yeah, we see each other soon for sure. Thank you so much.
Thanks.